Lunch?
Yes.
Yes.
Everybody looks pretty happy.
Yes.
Make sure you stay awake, so please get the coffee. We still have a minute. Because I don't want to see anybody asleep in my session. I'm just kidding. Okay, it's a pleasure to be co-chairing this session with Professor Koda. My name is Milan Kire. I'm professor at the University of North Carolina, Charlotte, in the United States. And it is a pleasure to be here with the home university of Professor Koda and Professor Magdalena. And it is my pleasure to introduce our first keynote speaker, Professor Magdalena. I don't have her full bio, but everybody knows her, right? Everybody knows her. She's probably the most noticeable. She was even more noticeable in Mumbai when we were there 6 months ago than me and Professor D.N. Singh. Everybody knew her. So that introduction, I'm going to let her come and talk about waste management.
I'll do my best.
Thank you.
Good afternoon, ladies and gentlemen. Once again, good afternoon, ladies and gentlemen. And the topic of my presentation is: will we or we will not be able to track with sustainable development goals in waste management? That's the question. When we think about environmental problems we are facing nowadays, definitely is air pollution and climate change. Everybody is talking about the climate. Also mining, extraction. We are extraction even in extreme level nowadays. Water pollution. If you will Google, you will find hundreds of pictures like that from all over the world with the plastics, microplastics, and other pollution in the water. And sewage and polluted water and wastewater. Deforestation, it's another huge problem we are facing nowadays. Urbanization, and going on, another huge problem which we have is overpopulation. When we look at the numbers at 15 of November 2022, human population crossed 8 billion human beings on the planet Earth, which is a huge number. And all of the problems I was showing before, it's rooting from our overpopulation. So there is no planet B, and we should start to do something about it. And that's the idea behind the Sustainable Development Goals, the 17 goals. So when we look at the problems also, it's unequal distribution of wealthness. So there is a huge gap between rich and poor. There is another problem, like you can see here. And of course, lack of awareness. Most of us hardly ever we think about waste, about the amount of waste we are producing daily, and the consequences. These are the consequences. Talking to waste and waste problem, actually waste is connected almost to all SDGs of the 70s, but the most is maybe with number 3, number 6, number 13, 11, and 12. In the past, the waste problem was generally local, and the waste was biodegradable, so there was not a big issue. But when we look nowadays, we can say it's a all over the world problem. These are pictures from China. This is India. Russia, actually, it's very difficult to get any statistics, what's going on over there. United States, New York is facing a huge problem with waste collection, with rats and insects all over the city. And Poland, a country I'm coming from, we are also facing a lot of problems, even though on the statistics it looks much better. But if you will go on a landfill site, you will see the difference. And another huge problem in Poland are also landfill fires. According to the World Bank's Water Waste report, the world generates more than 2 billion of tons of municipal solid waste annually, and less than 33% of the waste is managed in an environmentally friendly and safe manner. There are some statistics, how does it look like with waste production? The biggest producer of municipal solid waste is United States, then China, Germany, France, Turkey. Poland is also not doing very well. When it comes to food waste, which is another huge problem around the world, you can see the statistic: Nigeria, Greece, Iraq, Saudi Arabia, Australia are the biggest producer of food waste. It is estimated that 1/3 of food produced for human population is being wasted during the whole chain, from the production till the end of life. This is actually my student on a composting plant. We were doing some experiments, so you can see a lot of food is being wasted. So, trying to answer the question if we will or we will not on the track with sustainable development goals in waste management, it's a difficult question. I mean, it's a question of changing the way we are behaving, the way we are buying, the way we are storing, the way we are using things, of course, and the very important end of life. And another problem which I can see is that mostly we look at the end of the problem, which is the end of life of the products, the end of life of our stuff, so the waste. And we should start from the other side. We should look at the beginning of the chain. I think we have seen it today already, is the waste hierarchy. So at the very, very top on the turnaround pyramid, we can see prevention. And I think we should start with the prevention. And the very, very bottom you can see is disposal, which unfortunately in many countries is the most used way of treating waste. When we look at the statistics, I think Poland is something like 50% of waste is being landfill, Czech Republic 50%. Some countries are even 90 or 80% waste is being landfill. Why? Because it's quite easy and quite cheap compared to other methods. And the other thing, we don't have enough installation. This is the case of Poland. We don't have enough facilities to treat the waste. And I had the pleasure to spend 6 months in Japan, and I've got my lesson, and I think we can try to follow them. There is a very nice word in Japanese, mottainai, which means don't be wasteful, or what a waste. And it is showing that we should start, as I said, that our waste can be useful, or actually we should even not use the word waste, because when you look at the nature, there is no waste in nature. There is everything in cycle, and everybody is talking nowadays about circular economy, about circularity, about closing the loop. So I think this is the direction. And the beauty about the mottainai in Japan, it's that to our classical reduce, reuse, recycle, recover, they add something more, which is called respect. And I think this is what we are missing nowadays in many countries, that we are not respect things we have, we own, we buy. So we should start with the respect. Yeah, I have some pictures. I'm pretty sure, I'm glad rector is not here because it's from our campus. Yeah, I'm a little bit afraid that I might have some problems, but actually this is our waste point, very close to Ikar Hotel. It looks like that. So again, I think we don't have the respect, and it's again beginning with the education also. So we should educate people. We should show them the way how they should be aware. Another picture, it's from Japan. This is also from campus at Okayama University. So it is possible. Yeah, and as you can see, the PET bottles, this is a resource. We can use it. It's easy and it's reusable. In my country, in Poland, and in many European countries, we have a mixed plastic waste, which we cannot use. Because actually we have polyethylene, polypropylene, and all the polymers mix up together. And in fact, it's not recycling, but downcycling generally. And checking also, generally all over the world, there are no facilities to treat. So everybody is talking, yes, recycle, recycle, but how? So what we can also do, there is getting more and more attention to green nudges, which means gently push individuals into right direction. So just show how we can, what we can do to respect, to be respectful. Yeah, this is the nudging. a very nice example of nudging and a zero waste. It's a small Japanese city, Kamikatsu, on Shikoku Island, where in 2001 they signed a declaration, Go Zero Waste. I think actually it started in Australia in 1996 when they signed for zero waste. And all over the world there are coming more and more cities with zero waste idea. Like I think California is also fighting for zero waste, Stanford University, many universities. So also universities are good places where we should start the idea, the spreading, the green nudging and the respect and zero waste. And there are some examples how easy we can solve, for example, food waste. Composting is not always easy because you need an effort, you have to take care. But this is a nice Japanese Kiero composting, the Kiero composting. I will not tell details, but it's my dream come true to have something like that at our university, that everybody can use it and can use it for the food waste. Another way, it's bioreactors or small reactors which can be used in cities, universities, schools or restaurants, so that if we produce the food waste, just to do everything to bring it back to the loop. And there is a very nice example. I had an opportunity to visit Indian Institute of Technology, and actually at their campus they have a lot of places with small composting facilities or I don't know how to call it. Very easy, where they collect the food from the canteens all over the campus and they compost it, and the compost is used at the campus. Yeah, this is how it's look in Mumbai. Also, very nice idea, they have a biogas station, which is actually using, again, the food from the canteens. Many Indians are vegetarians, so a lot of food waste is being produced. So at the campus, they are using it to produce biogas, and then the biogas is used in the kitchen. So, Professor Koda, it's my dream to have it at our campus. Thank you for your invitation. Another good green nudging is a clean bag policy. Actually, it started in Canada. I don't remember this small town, but they try to change our common black bags for waste on transparent, which means it's putting a moral tax on individuals. And in Canada, they started all the bags were black, but only one transparent, and only one was black for very, very personal waste. In Japan, they went even further. You have to put, in some parts of Japan, you even have to put your name on your bag. Of course, people were at the beginning very annoyed because they were saying, everybody will know what I'm producing. Well, yes. So this is the moral tax, this is the respect. If we will see, if I'm bringing something what should not be in the bag, this is the green nudging, okay, they will see. So, so I think it was quite successful. It dropped the municipal mixed weight, I think more than 20%, and increased the separation of waste. This is a back picture from Bombay. I'm sorry, it's from Indian Institute of Technology. It was an event over there, and I made a picture. I can't help myself. And on the right side, it's a very easy nudging. You know, Eco Station, it was in Okayama. It was an event for students. And what they did, they put the students as volunteers, and they were showing how to separate the waste, which is easy and really helpful because generally on events, we are producing a lot of mixed municipal waste. Yeah, this is the Motainai and clean bag policy. This is again from the university, and the students are volunteering, helping to keep clean after the event. And the last thing, you know, when you look at the picture, probably it's from United States, the left one. I'm sorry. And the right one is Japan. We can also reduce the amount of waste we are producing, the food waste, the gastro waste from gastronomy, very simply, just using a small bowls. It is scientifically proved that if we put a lot of food on one plate, we will eat more and we will waste more. So an easy, it's from a G terrace in Okayama. Hello, Bernard. And I think it's reducing a lot. And this is from Indian Institution of Technology. Again, I went there and I could see they are using the small bowls. And they had a huge sign, "Don't waste food," which I appreciate very much. So it's another example how at the universities we can show the students the right way, because nowadays we have the Generation Z. In few years they will leave our universities and they will spread all over the countries. And if they will get a good lesson, you know, how to behave, probably they will take it to their families. So the answer of if we will, all the SDGs we already know it will not be possible to achieve till 2030. But I think the most important is, and actually we are doing it nowadays, it's the international cooperation. Because it's not like that country A is producing waste and country B is not producing or not producing. We have only one planet. And you know that some countries are selling their waste to other countries. It's not the solution, you know, because it's only moving from one place to another. It's like with pollution. You know, there are no borders for the pollution. So I think the international collaboration and the awareness and, in my opinion, the respect is the most important in our future, in the future of our waste. Thank you very much.
I think we have time for questions. Because discussion. Yeah, but if somebody has, yeah, go ahead.
I'll go. Hi. So my question is, do you think the problem with the circular economy, it's the part of the economy, because we still didn't find a way to make wastes enter the economy loop. So if people are making money with this product, waste, of course it's going to run by itself. But I think somehow the circular economy is still missing the economy part. We know how to do circular, but we don't know how to do full economy with it.
I'm not sure I fully understand your question. I mean, how to bring back the waste to the circularity, or?
Okay, if people see waste as a value, you will start to make economy with it. My question here is if you agreed with this.
Well, everybody knows that recycling is very expensive. I mean, it looks beautiful in the books and on the circles, you know, recycle. But as I said, mostly we do downcycling, which means the products we will get, it's going down, the value is going down. So with the PET bottles from Japan, yes, I do think they can use it. I was in many, they don't have nowadays landfill, they have like centers, waste management centers, and they do biogas and they do composting and recycling, and they also have a landfill. And I have seen cans and bottles. Actually, we were together, Alexander, remember. And yes, then you can use it if it's well prepared. So one question is how we separate our waste. Unfortunately, you can see how we do it. And so the quality, let's call it, of the waste. And of course, then, as you said, we need somebody who will buy it. Yes, so the price. I have a friend, he's working in Arab Emirates in a company Sabic, which is producing plastic for all over the world. And he's saying nobody is buying recycling materials because it's more expensive. So we have to force the prices. We have to force, if we will not change. For example, in Czech Republic, the recycling, Czechs are quite good separating waste, which means the plastics, they are top in Europe. But it's not the solution because, again, it's mixed, everything, polyethylene, polypropylene, polychlorine, and so on and so on. And there is no interest in this material. So they rather use concrete, for example, than the recycled plastics. So I think we should start from the beginning. So don't produce waste. And if it's avoidable, if it's impossible not to produce it, then to try to keep it as good quality as it is, if it is possible.
Thank you.
Well, thank you so much. We'll keep going, but before we go to the next presenter, I see a lot of people sitting in the very back. There is a lot of room here. And It's
like
okay.
at school, you know?
So if people want to move forward, please do that right now.
It's like in school, all the
Yeah,
students are always back to
and
class.
unless you have a reason to go to room A and B, you're doing back and forth, you should just be comfortable here, okay? All right, well, with that, our next presenter, well, thank you, Magdalena, by the way. So, our second presenter here is going to talk about combustion slag. So it's about waste reuse, waste byproduct reuse. And the presenter is Katarzyna Gabrish.
It's okay.
And Wojciech, how you say the second one?
Wojciech.
Wojciech Sas. That's the hard one. Katarzyna?
Yes, thank you. Ladies and gentlemen, good afternoon. My name is Katarzyna Gabriś. I'm representing the Department of Geotechnics, Institute of Civil Engineering, Warsaw University of Life Sciences. It's a great pleasure for me to be with you today and present my research. One of the subjects of my research, as well as my speech today, are waste materials. And I would like to introduce you slag, one kind of slag, byproduct of co-combustion, which is formed in the power plant. And we are working with this material, not only this one, but I'm talking about this one today. We are checking its different geotechnical properties, including perhaps especially dynamic ones. Are they similar to natural soil, natural aggregates? Let's check. So, co-combustion in the power industry causes a big emission of pollutants into the air, as well as the production large amount of solid byproducts, not only slag but as well ash. And from the perspective of the circular economy, it's necessary to seek for the new applications for these materials in the industry. Model concept consistent with the circular economy assumes the use of slag in a broadly understood construction. So we can find many different various concepts of slag applications. For example, ceramic industry, road construction, cement industry, land reclamation, and so on. And the construction of roads and motorways has further increased the opportunity to use combustion slag, provided they meet some severe criteria. And when I'm thinking about these requirements, one of the great important requirement is to understand the dynamic properties of CS mixtures. So I'm thinking here about the shear modulus G and damping ratio D. For those of you who are not familiar with dynamic properties, I will just say that there are two essential indexes for seismic performance analysis and safety performance evaluation of terrains and structures who are located in the areas, seismically active areas or exposed to various vibrations. And dynamic loads acting on the structures, like for example wind or earthquake, they vary with time. They do not follow a constant pattern, they are sudden. And we can find several types of geotechnical engineering problems which are connected with dynamic loading. Such of them you can see here on the slide listed on the left. So the aim of my research was to investigate shear modulus and damping ratio using a very common non-destructive method for natural soil. It means resonant column technique. And to derive the CS stiffness, I used the frequency response curve, which will be shown later on, and to derive damping properties, damping ratio of this material, I selected the free vibration decay method. So we are in Poland, in Warsaw. Let's go to Siekierki power station, power plant. It's the Poland's largest power plant, the second largest in Europe. This is the place where I took my research material, combustion slag, non-slurry material, irregularly shaped, predominantly porous, glossy grains, gray in the color. Here in the table you can see some selected physical properties of this material. Let's look on the grain size distribution curve. You can see here as well some typical grading characteristic typical for natural soil, together with the coefficient of uniformity, coefficient of curvature, using the soil classification, unified soil classification system. This material was classified as sand or sand with silt. You can see some chemical composition. Unfortunately, I haven't done any chemical test. This is what I found in the literature about this material. And I found as well that it's characterized by a stable chemical composition does not exhibit any environmental hazardous properties. The laboratory tests were made here in this building where we are right now, in one of geotechnical laboratories, using already mentioned resonant column technique. You can see here on the photo the device together with all the instrumentation. So I conducted research on 3 specimens, CS1, 2, and 3. All of them were prepared in the layers using a dry tamping method to get the derived relative density of compaction. And of course, first we did flushing, then we were saturating our samples using back pressure method, checking the value of the Skempton's B parameter. Then all the samples were isotropically consolidated. And finally the damping test. I started with the resonance test and resulted in the frequency curve, which you can see on the figure on your right, the top right. From this curve I got the resonant frequency, then later on used to calculate the stiffness of the material, so the shear modulus. And these tests were followed by the damping test, resulting in the damping curve. I calculated the logarithmic decrement and later on the damping ratio. So we are moving to the results. Due to the lack of the time, I'm presenting just some of the results. The details of them you will find in the paper. Here, for example, is the all these features are showing that dependency of G modulus and D ratio versus shearing strain. The characteristics are very similar to what we can observe in the natural soil. So we can see that the shear modulus is decreasing with increasing shearing strain in the range of small strains. Here I'm thinking the strain is on the x-axis. When we are thinking about small strains, so between 10 to minus 4, 10 to minus 3%, there's decrease in G is around not more than 10%, and when we are going farther beyond 10 to minus 3%, the modulus is decreasing more, up to 40%. Then we can see as well the effect of the mean effective stress, right? The higher mean effective stress, then we are getting the higher stiffness. The same, there is a dependence of the relative density of compaction. When we are looking at the damping properties, right, they are increasing with increasing shearing strain. The increase is rather small in the range of small strains and it's getting bigger when we are moving to the larger strains. Another example of the results, the figures on your left, the Gmax and the Dmin versus mean effective stress. I used here like the common power law function to check this dependency. When we look at the Gmax, the function works pretty well. The R square I received is 0.99. In the case of the Dmin, I used the same function, but the R-squared, the values are smaller from 0.66 to 0.92, depends on the specimen, so I think more tests are needed, more samples. And the results on the right, the relationship between Gmax and d-mean versus relative density of compaction. In the case of G modulus, small differences between the small strain shear modulus. In the case of maybe just at the low pressures, because there's increase by 18%. In the case of the damping properties, we can see there is a decrease. The difference is bigger between the results, between 58 up to 83, depends on the mean effective stress. But when we are getting like denser samples, well, this dependence is not observed. So some concluding remarks, because I don't have more time. So the G modulus of combustion slag decreases and the ratio increases with increasing shearing strain, right? So no matter which was the mean effective stress or relative density, the tendency, the variation is the same, right? Then when we are thinking about the smaller strains, smaller than 10 to minus 3%, as mean effective stress has a remarkable influence on the studied parameters of combustion slag. This power law function proposed for Gmax moduli, it works for the damping properties. I think better to search for another better relationship between these two parameters. So I think more tests are necessary. Relative density of compaction, greater effect on Gmax of combustion slag, but with lower mean effective stress than higher on d-mean, just considered relevant for loose or medium dense materials. And the last one, maybe the most important perhaps. So I can see, these are just the preliminary test results, but I can see that it's a really high similarity in dynamic characteristic to natural non-cohesive soils. This may result in the future utilization of this material as a possible substitute for natural material in practical geotechnical engineering. And thank you for your attention.
We're gonna keep going. I think we'll keep going. Maybe we'll have questions. Can you hold on to them at the end? Because we have a discussion session. So with that, our next presenter is gonna talk about construction and demolition waste from Republic of North Macedonia. And we have a speaker, is it Donevaska Katerina? No? Who is presenting? Johan? Okay, so we have Johan Papik here. So, thank you. Oh, that's right, yeah.
So, thank you, Professor Kire, for the introduction, and thanks to the organizing committee for selecting this paper for presenting in the oral session. So it is 4 persons having participating in its preparation, while the leading author is Professor Katarina Donevska. She is professor at our Faculty of Civil Engineering, and she has been dealing with landfills for more than 20 years, either in the design or participated solely or in a team in a preparation of some legislative regarding landfills in North Macedonia. So part of her recent researches are given in the paper, and these are from the point of view of construction demolition waste. They, beside the 2 definitions that are given at the beginning, they can also have in nowadays similar origin from natural disasters, unfortunately. And what can also be related to them is that they are occasionally related to illegal dumping. So generally, as we will see later, a lot of quantities of construction demolition waste has been produced in member states of the European Union. There is high potential and, of course, high need for their reuse. And in order to that way reschedule the civil engineering and construction and demolition waste from linear to circular economy. There are numerous benefits that are given below. So in the paper, there will be some review on what is going on in Europe and what is going on in North Macedonia. In that direction, so about 16 years ago, there has been adopted the so-called Waste Framework Directive, according to which the European Union has been asked by each member state to develop their waste management plans and, moreover, to try to increase the recycling of the waste frame of construction and demolition waste to more than 70% by 2020. In order to stimulate it, also so-called protocol has been brought, where among the rest there has been criteria for the waste, and that is all in direction to increase the confidence and on construction and demolition waste, and stimulate the management process. So what's going on in Europe in the last 10 years, so from 2010 to 2020? What is public opinion generally is that we produce a lot of household waste. But if we look at the total quantities, we can see that household is only 8 to 9% from the total waste that we generate, and that in fact the construction and demolition waste is 34 to 37% from the total quantities of waste. So the household is 1/4 of the construction and demolition waste. Unfortunately, we have noted that according to the Eurostat, so the recent data, fresh data, it has been, the construction and demolition waste has been increased from 34 to 37% in the last 10 years, while at the same time, as you can see at the bottom, the mining and the quarry waste has been reduced, so from 29 to 23%. So relatively, the construction has been increased by 10%, while the mining has been decreased by 20%. If we only look at the construction and demolition waste, and if we exclude the excavated soil, we can see that the percentage of concrete, bricks, tiles, and asphalt is almost constant of about 90%. So generally, the situation is that so far, but how are the member states dealing with construction and demolition waste? So there are more or less 3 categories. So either it is landfill, either it is backfill. Landfill at the bottom, backfill at the up. But you can notice that most of the construction and demolition waste has been recycled. I hope that it will be the case as it is now going on in the Svijeto-Kržiška street. There is a huge demolition going on, and it will be contributed in these percentages. So we can notice that the Waste Framework Directive, adopted in 2008, already brought results 4 years later, when in 2012 it was the recycling has been increased to 76%, and later it has been stable, increasing slowly, but stable, reaching up to 80% in this period. While for the landfilling, it has been reduced for about 20% in 12% in these 10 years. Overview of each member state has been given here. We can see numerous various results. Each state, what kind of management they prefer with construction demolition waste. So plenty of varieties are given, unlike the countries from the Balkan region, where landfilling is unfortunately the most favorable approach. On our marathon road to the European Union, Macedonia has brought the first law on waste management in 2008, so it's the same year when European Union. So Professor Doneska participated in some other rule books that have been accompanying this law, while 3 years ago a new law on waste management has been brought, giving more clarification and being more correlated with the one in the European Union. Unfortunately, the situation with the landfills in the Republic of North Macedonia is so-so. There are landfills. They are mostly ruled by municipalities. Some are sanitary, mostly are not. So as for the construction demolition waste, usually it is collected by so-called informal sector. They are illegally dumped, so we are missing a lot of data. Luckily, that's not the situation with the landfill Drisla that is serving the capital of North Macedonia, Skopje. And so it has been in serving process for 2-3 decades. And according to this recent law building, it has been increased accepting the construction and demolition waste, since Skopje is generally under huge urban offensive. So before bringing the law, up to 10 or 12% of the total waste that has been collected in Drisla has been from construction and demolition waste, while after adopting it, so it has been increased almost double. So in order to keep progress with this way, we will need to develop and put in force the effective legal framework. So it's not about just having the laws, but of course respecting them. We will have to establish more closer cooperation with construction companies in order to get valuable data for the quantities. Of course, it has to promote the selective demolition and reuse recycle of construction demolition waste. In that sense, there are plans to develop regional sorting facilities and, of course, to promote their and to support them. In that way, we will try to contribute in balancing this in equation. Thank you.
Well, we're doing very well on time so far here. So we're going to have more time for discussion. Okay. So the next speaker we have here is going to talk about circular economy in also construction and demolition waste. And the speaker, I believe, is Joanna Fronchek. Very nice. Okay, thank you. Yes.
Good afternoon. My name is Joanna Fronchek, and together with Good afternoon. My name is Joanna Fronchek, and together with my colleague Katarzyna Markowska-Lech. Okay, and now it's okay. Once again, good afternoon. My name is Joanna Fronchek, and together with my colleague Katarzyna Markowska-Lech, we prepared the paper entitled Circular Economy in Construction and Demolition Waste Management, and this is literature review paper aimed to examine different waste management strategies for construction and demolition waste. The goal was achieved by searching scientific publications, regulations, and statistical data, and to outlining a sustainable system of construction and demolition waste management. So we already know from the previous presentation what actually construction and demolition waste is, and what is the composition or can be the composition of this type of waste. However, I would like to underline here that the origin of waste is very important because comparing, for example, construction waste and demolition waste with waste generated during natural disasters, these types of waste, of course, differ, and wastes from natural disasters are exposed to risk causing substances, and that's why it differs from the waste generated during control activities like construction and demolition activities. So as we know, construction and demolition waste accounts for at least 30% of all solid waste generated globally, and in European Union even more. That's why shifting from linear economy to circular economy is so essential, especially when we take into account that up to 75% of C&D waste can be reduced. So circular economy system consists of 6, here are 5, but I will show you 6 also, 6 levels or elements. So first of all, we have waste mass reduction, or other words, prevention, waste prevention. And according to literature, waste minimizing, reduction, or prevention may significantly reduce the cost of construction work and definitely reduces the consumption of raw materials. And this can be achieved by or through financial instruments like fines, emission fees, landfill price increases, or more consumer-friendly tax benefits. It can be also achieved by eco-design, or what is very important, work organization, like optimization of supply chain, work schedule, product and waste storage conditions, and this can be can be achieved using different kind of optimization tools like building information modeling or geographic information system. So the next 2 levels are waste identification and waste collection that play an important role in achieving the quality of stored waste, and as a consequence the quality of the final product. So as you can see here in the picture, demolition waste and also waste generated during natural disasters or war. This is the mixture of many fractions that quite often are difficult to separate. Nonetheless, in many countries are introducing right now regulation standards that choose the selective collection of construction and demolition waste. For example, in Poland, starting from 2025, we will be obligated to collect construction and demolition wastes in many categories, let's say. So wood, metal, glass, plastic, gypsum, and mineral waste. So the next 2 levels of circular economy is waste treatment and final product or end product. And one of the most commonly used methods in practice, and also most widely reported in scientific publication, is the processing of mineral waste to produce recycled aggregate concrete, mortar, bricks, different kind of panels. What I wanted to mention, to underline here, so we use different processing technologies, and at the end we have final product or end product that we propose to the industry. And of course, industry recycle this recycled or end products, but I have here one but, or not one. So there is a challenge for research community to develop new innovative technologies that will allow us to keep new fractions of waste in the cycle. New fractions, I mean not only construction rubbles or metals or glass, but also the other fractions produced during, for example, demolition. And also there is a challenge to develop new technologies that will allow us to standardize the quality of end product. I think here about the standards that are similar, for example, to the standards used for solid waste derived fuels. Yeah? So we could propose such kind of standards or certificates. So we have also here the quality management related to the quality certificates I mentioned one second ago, and the guidelines of technical conditions for use our final or end product. Yeah. Okay, so to not only emphasize the challenges related to circular economy of construction and demolition waste, here I would like to show you positive examples. One is Highline in New York. This is an urban park located on a former train line in Manhattan. And the second one is the single family house in Żabia Wola. This is the example from Poland, where wood and glass from demolition of an old house was used to construct this new beautiful building. So the sixth level of circular economy system is logistic, and logistic is usually understood as transportation. However, in my opinion, together with the quality, the limitation to increase the share and good publicity, let's say, of recycling and reusing of construction and demolition waste is secondary market, because secondary market, in my opinion, is underdeveloped and requires support in terms of legislation, technology, and marketing. And this is all because of the high costs. And these costs are related to available waste processing technologies, lower awareness among representatives, and often, not every time, but often lower quality of recycled materials when we compare the recycled materials to so-called virgin products. So, summarizing, introducing regulations that support, new regulations that support audits, selective collection and standardized use of recycled materials is crucial. Prioritizing waste reduction, effective and safe collection, and proper treatment methods may optimize resource recovery while at the same time mitigating environmental impact, ensuring quality management, including technical specifications for recycled materials, and developing secondary markets, enhance competitiveness of our final products for the industry, realizing the full potential of circular economy requires a holistic approach, integrating technological advancement, legislative support, and stakeholder engagement. And finally, I would like to leave you with the question: do we have the legal, technological, and organizational capacity to close the loop? So, in my opinion, we are on good track. However, there's still a lot work ahead of us, yes, actually in all of these three areas. So, thank you very much for your attention.
With that, the next speaker, Arvind. Yeah. So, Arvind, yes, it's you. Yeah. So, Arvind Farid, Professor Farid is a faculty at Boise State University in the United States. I know Arvind very well. Arvind is a good friend. He's going to talk about food processing waste for ground improvement, and I don't want to take his thunder, but he's a technical chair of the ASCE's Geo-Environment Meet Conference, which is in Portland, Oregon in September. So maybe some of you are able to travel. Please join that conference. And if he has any questions, ask him any questions you may have. So with that, Arvind, it's all yours.
Thank you for the kind introduction and pitching in for the conference. Okay. Turn on my timer so we can see if I can stick to my 10-minute time frame. So here we're talking about recycling or reusing food industry byproducts. We'll call it FIP because the producer of the waste does not want their name to be revealed due to some issues not to be mentioned here. And the goal here is to basically solve multiple problems at once. Because we've been talking about solving one problem, but nowadays, with the extent of the issue, you got to target 2 or 3 problems at once and see if you could mix 2 or 3 problematic materials to solve all the issues at once. And this is just the outline, but the sponsor information, again, not to be revealed here. We call it FIP here. We have an NDA, but there are hundreds of these sites across the United States. Only one of them in Idaho produces 100,000 plus tons per year of the waste. City blocks per year are produced. And there's soils, organics, chemicals, heavy metals, and a large content of calcium carbonates, call them PCC, precipitated calcium carbonates in there. Currently, they just stockpile them, monitor the leachate, and it's an issue. Dust is an issue, and neighboring cities have been complaining. The smell is an issue, and so on and so forth. And there's potential for that. So this is one problem number 1. Problem number 2, and by the way, the result is you got to mine limestone, spend a lot of energy, heat, and CO2, produce CO2 to create lime out of that, and then use the lime to purify any product, food processing product, and the waste is what we just mentioned. That's the result of that. So you see there's a lot of carbon footprint in there as well. So can we get rid of the waste and turn it back to something useful? And these are some of the chemicals in there. And if you look at this table, there's a lot of potential toxic material in there that leaches out. So they have a big issue. The sponsors have big issues there. Based on the properties, there are applications that could be used depending on the geography. I don't want to get into all of that, but the one that I show an example here is to treat expansive clay soils within the state of Idaho. That's where I'm from. And obviously the anticipated problems, the high organic content in terms of the strength, the potential leachate, high pH, and so on and so forth. And this is just one picture of one corner of the site. And these are the third problem here is we realize that fly ash has been used in the industry and recycled in the US in concrete and some other purposes. But due to transition from coal to natural gas, the supply is low now. We ran out of the supply. So now that's a market, a problem and an opportunity right there. And there are similarities and differences to fly ash in terms of some of the properties, but the differences are mainly the organic impurity that exists right there. There's 20% unspent lime within this, so that's the potential. Also, pozzolanic reactions could happen because of the content, the table that I showed you. And some research has been done on different type of waste and their application. I don't want to get into the detail of that in the interest of time. In terms of the methodology, we looked at the strength, the swelling potential, because this is expansive soil. We're trying to mix the waste with expansive clay to see what the result would look like, and see if the clay would immobilize the contaminants within the waste as well. So the mutual benefits, in a way, is the target. And there's no standards. This is the first time we tested this. And we don't know what the blends and the fractions should be and what the outcome would end up being. But the hypothesis is mixing these two problematic materials together could result in an engineered product that's desirable. These are the series of tests after characterizing the clay and the waste, the FIP, as I called it. We created blends from 0%, meaning all clay, to 100% FIP. 15%, 30%, 45, 60, and so on and so forth. And after mixing, we ran a suite of experiments, hydraulic conductivity and unconfined compressive strength, Adaberg limits, and so on and so forth. These tests have been run, and then we decided to select what the promising mixtures are, SEM and leachate tests and so on and so forth. And a lot of other tests that I'm not showing here has been done. The first step was compaction curves were developed. From now on, you'll see a series of, oh, I thought my timer was working, it's not. A series of figures. Horizontal axis is the FIP fraction from 0%, meaning pure clay, to 100%, meaning pure FIP. And the vertical axis would be various properties. So here the first property is the dry density. You could see that the clay is pretty low, but when you add the FIP, 15% gives you a much higher density, and beyond that, everything is pretty much desirable. Now look at the shear strength. The clay is not that bad, 15% to 30%, 20% good, but then after that you get a reduction. This is hydraulic conductivity, which is quite interesting. You see up to 45% clay dominates what the hydraulic conductivity is and the magnitude, order of magnitude. Beyond 60%, the FIP dominates that, and that should impact the leachate. This is the swell potential. You see the clay is pretty bad, 18% is the swell potential, but as you add the FIP, that goes down to practically below 2%, which is very desirable right there. So that's the swell potential. So in a way, if you look at the properties, we're dealing with a non-plastic mix. So the mix at all fractions is non-plastic. So that's a great improvement in terms of the expansive soil target of this problem, but there's still potential for other embankments or other remediation and some other applications that we're currently testing. And this is the leachate. So you could, the bottom row shows the FIP. You see everything is in hundreds or thousands or tens of thousands in terms of the concentration. But if you look at the mixtures, they're pretty desirable in terms of chromium and manganese and copper and so on and so forth. So pretty much the clay helped. And interesting enough, the mixture is, in some sense, is even better than the clay because of the interactions that you see over there. But in terms of sustainability, you got to consider all different aspects that you could see on the right vertical axis. And depending on what the use is, you could pick which percentage, which fraction in the blend should be used. Do we care about the strength? Do we care about hydraulic conductivity? Is the leachate or the swell potential the target problem that we're trying to resolve? So I think with that, I'm 1 minute ahead of time. So, and okay. Conclusion-wise, the blends were non-plastic, which helped this fat clay, high plasticity clay that Idaho Transportation Department has been dealing with, and has a big source of light structure, infrastructure damage. The dry density of the mixture has improved. There was, I didn't show those results, but in terms of friction angles, not much of a difference. In terms of the cohesion, not much of a negative impact. And the hydraulic conductivity, there's a regime change that I mentioned. And the blending reduced the swell potential and the strain, which was a positive. And leachates were immobilized. Interesting enough, some even better than the clay. So there are some interactions in there that are useful. And the particle packing through SEM, we saw interesting results. No room here to show that, but that was quite interesting as well. That I have another talk in Portland that we'll discuss. Okay? Any question? If there's time, I try to respond. If not, after the fact.
We have
Thank
time if you have somebody has a burning question. Otherwise, we can have plenty of time for discussion too. But if somebody wants to ask a question,
Oh, microphone.
okay. Looks like there is one here.
By the way, we're still running the leachate test and over time, and we want to try temperature change and see what the impacts are. So this research is still ongoing.
Thank you, Professor, for your insightful presentation. Like you have shown some hydrometer, like you have done hydrometer analysis. But in conventional geomechanics, like for inorganic materials, we do mostly hydrometer analysis. But like, what problems you faced, or is it like, can we perform hydrometer analysis on organic rich material? It is.
Oh, what do you mean? Can you perform hydrom?
Yeah, because like they will mostly hydrophilic in nature, organic matter, and if you are exposed, like what is the principle of hydrometer is like just we allow settling it in the water column. So.
Oh, you're talking about the grain size distribution of this. I thought you said hydraulic conductivity test.
Hydrometer basically.
Okay, hydrometer. So. Because of the organics in there, so now okay now if so basically if you repeat the question now that I figured out what it was, so that
I think he's asking you, how is this test applicable to organic matter? Isn't it supposed to be for inorganic soils, and how did you do this test organic matter
for the grain size distribution of that?
Yes.
It's, I mean, you add, I mean, that's always an issue. It was just to figure out the grain size distribution in terms of the packing. Otherwise, I didn't even show the hydrometer test results here for that purpose. So if I answered that question correctly.
So hydrometer was not done really on this one?
It was done, but it was problematic results, so it was not shown here.
That makes sense, because the particles would be all attached to each other. They wouldn't come down.
We tried different, more concentration of calgon and different ways and adding chemicals. Still, you get some results better, but still problematic. That's why I didn't show it here.
Okay, no problem. Thank you so much. We'll continue the questions. I think the next. I have one request. I don't know, I could hear the talk from the other room or something. If somebody's in the door, do you mind closing the door for our last presenter? So with that, we have the last talk of the session. We're going to have discussion after that. So please hang on to your questions. We're not rushing you. So everybody will get a chance to ask questions. It's not on? Oh, okay. Okay, can you hear me now? Yes. Okay, I'm going to repeat it now. All right. So the back door over there, I could hear the people from the next room. If we could close the door, that would be great. Okay, it's closed. All right. Second question. The second part is we're going to have plenty of time for questions. So hang on to your questions. We got one more speaker, and then we're going to open discussion. All right. So with that, I'm going to introduce the last speaker here, who's going to also talk about circular economy. Is it also from Warsaw University?
No.
Okay. So the next speaker, who is presenting? We have Nono Dinis Kortikos. Okay.
Hi.
All right.
Okay. Good afternoon, ladies and gentlemen on the stage. Well, first let me tell you that this is not my topic. I answered this invitation from Miss Anna Stefanska. She should be around here. And she told me we have to go to Warsaw to participate in this conference. And I was like, but that conference is a little bit out of my topic. And she said, try. So I went out of my topic. So this is not natural for me. This is not a topic that I research. So everything can go really wrong. So I'll feel, because I'm Portuguese, and I will speak about Polish waste. So I got some problems here. I'm feeling like Cristiano Ronaldo scoring a penalty and probably will be defend. So so I'm pretty in a hot spot here, but let me give you a try. So first, I don't know much about this topic. I went and tried to understand from my point of view, and then I realized that Poland is really big when it comes to waste production, mostly from mining and quarrying, not so much from construction. Poland actually is strange in the European scenario, because all of the countries tend to have like 35% of construction waste, but because Poland has so many mining and quarrying, the number of waste, although it's, if you take it out, the mining and quarrying still the same. If you don't take it, is really different. But the Polish market, when it comes to construction, is really strong. I was not aware of that. they in 2020 came in fourth in terms of construction economy, let's call it. So I put some numbers over there. And this was the first thing I realized. Then I went to the European data because, you know, Europeans pull the shots in Brussels. So, and you already heard about this. They want us to achieve the 70% mark. And every country is doing their efforts. And here too, I think they changed the law and raised the taxes on disposable products. So probably you're paying more at the supermarket and also for the constructions and homes, residential, shoppings everywhere. So, but this is also a trend in Europe. So you are not pulling anything new, you're just coping with what it is already implanted in other countries. And you know, some countries like to push the shots first, like the ones they ourselves call big, France, I don't know, someone here from France or Germany, they want to, usually they give the example and they push for these ones. So we have this policy, we have the waste goals, and these legislative updates that we see everywhere. Poland is performing quite well on this, but let me tell you, because all the stories got a little bit details that changed things. And I was when you look from outside, and I'm from Portugal, so I'm near the Atlantic Sea, and for me this is quite far. It's like 4-hour plane here. And then I realized that the Polish situation is quite different because, first, you do a lot of mining because the coal, right? Because the energy. But before the war in Russia, coal was being phased out, right? So many people were losing their jobs. So what the European Union did, the European Union stepped up and give Poland money to build up incineration sites for waste. So Poland built a lot of incineration factories here. And the jobs were facing down on mining, and probably they were be taken at the incineration. So you built a huge capacity for incineration waste materials here, especially when it comes to construction. And why construction is so important. And I was stressing this with Magdalena, is because in construction, the numbers are so high. You know, I don't know if you are aware, the construction usually in Europe is the first sector or the second sector in economy. So meaning that there is so money involved in construction, it's so many materials that you easily build the economy with construction. So this is what European is pushing so hard on this construction and demolition waste, because it is easier to do it than the other, like food process waste. Okay, so knowledge. What's the knowledge say? Because I didn't know either, so I had to look about this. So they got some barriers that I understood: economic, environment, and social. And I think you are aware of these. These are hot topics today. And also, people tend to some people they pretend to do recycling by using probably the plastic bags. But maybe inside the plastic bags, recycle is not so good, right? Sometimes I don't want to break this apart, so let's put it in a paper or something, it's a little bit of plastic. So also, this circular idea of the part of the economy, it's really hard to put on end, because who want to buy waste here? Anyone want to buy waste? Because we don't know what to do with it. So you don't want to buy it, you don't see value on it. So this is why the construction sector is so important, because it can lead and can teach us how to reuse it and build up new buildings, so you already know about the recycle of concrete and so on. Although, and this didn't all, because scholars are involved in these knowledge dissemination papers everywhere, every time about this knowledge is really our topic. Another thing is the carbon savings. When you capture some of these and you don't process and emit them on the environment. Of course, the potential of cost. I don't know if you are aware, nowadays we have, because I wasn't, because this is not my topic. Again, I discovered there is a market for waste. And, by mistake, I subscribe this website and they keep me sending emails like, you should invest in waste. It's now growing, Kagar is going 5% next year. I was like, oh, I was not aware I can make money with this. So maybe waste, and I don't know if you follow me here, will be the next crypto, okay? But I'm not here to give financial advice, please. Don't take me for real. But can be. I was very impressed. Okay, so of course we have many, waste is really complicated. As Magdalena said, waste is kind of a chaotic thing. And when you when you're showing those images about the waste here at the campus, I always say to my students, in a way to build up order, you somehow hence to build also disorder. If you want a order here, you have to have a disorder here. It's not possible to do. If you do a construction, you have to have some rubble, right, around the site, and then you have to take the rubble and put it in at a place. So this is a problem because to be clean, you have to clean it, and when you clean it, you have waste. So waste tend to be a mashup with really strange things, with sharp hands and really smelly. So it's really hard to separate waste and to treat waste. And you need a lot of people. That is, in Europe, is impossible because the end labor is too expensive. Or you need to engage machinery, like AI machinery, that can see the waste and separate the waste in more value from low value, and maybe the high value you can use it, and the low value you should probably burn it and take the energy out of it. So there is best practices. I also learned this. The idea is always reduce the waste. Try to the waste goes in the news cycles. For instance, I have kids. I always ensure that the toys of my kids go to other kids. So every Christmas, a younger kid gets happier, So they go happier until they break it, I think. So somehow they will end it. And maybe someone will buy that old plastic and build new toys, so the kid's going to be happy again. And kids are important because the economy doesn't work without people. This is a problem that we have in Europe because to undergrow economy, you have to have kids. So policy, yeah, it's true. So no other way. Okay, stakeholder collaboration is also, there are many. So my methodology was really simple. I isolate these kind of products, and I build up some. I was going big in the beginning. I was like, oh, I'm gonna involve Portugal, Spain, France, Germany, and last Poland. But then I realized it was too much. And these barriers, they take too much time to answer. I asked them for the statistics. They can take, for instance, in the Portuguese case, it was like a week, but the French didn't answer yet. And I start like, this is in February, so you see, it's quite difficult. So I brought Poland. Because COVID was involved in our lives, was also involved in waste life. So you can see the numbers does sometimes go wobble, going up and down. This chart is really boring, so we should go to this one. It's more aligned and understandable. And because you have to understand, I'm an architect, so I like to simplify things to understand them. So if you see that curves over there, even if we take the really difference when it comes to COVID, you can see the lines of Europe and Poland are not so different. So Poland is being a quite good student here. It's following the professor. Well, I don't know, is the professor, maybe it's the opposite. Maybe Poland is the professor and the European Union is the learner. But Poland is really going with the trends. So policies are working here. Okay, what's my results are? So first, Poland have a decrease on investment around 19 in terms of construction or construction demolition waste products, because you had some problems, you have some crisis in construction around 19, so you decrease the investment. But then European countries start to invest in Poland more, and you took the lead in 2021. In 2022, you were the fourth country in grow in construction. When you go in construction, like I said, you also grow in waste. There's no way. Okay, you have to do it this way, no problem. So in terms of recover, you also following the line. So you're going after also the trends. you're trying to recover on this side. And another thing that I realized, and because the Macedonia colleague is here, north of Macedonia, sorry. What I realized is small countries tend to recycle more than big countries. And this is understandable because, small families probably operate better. You see them in the restaurants, right? If it's a small family, like, I don't know, a couple, they are quiet. But it's like a big family, a couple and 5 kids, they are always in the party, somehow. So small countries are also better when it comes to recycle than big countries. So I think the mass builds up mass. Okay, so this was the trends in the construction investments. Poland really hit the brakes on COVID. I don't know why. You really get stressed. COVID was a big thing in construction here. You hit the brakes. You went even way far at the end, the average. But then you start to recover again, and now you are aligning with the European trend. So, key conclusions. I said that although Poland doesn't follow the same path of European Union, and doesn't have to follow, in the end, the outcomes quite align. So I can say Poland is a good learner of European policies. Maybe I'm late, right? Usually I'm late. In terms, employment grow a lot because in the incineration factories that I told you. Today, Poland imports waste from other countries. I don't know if you are aware of this. So, and I can tell you, sorry if this sounds bad, but Poland is treating almost the Germany waste. Okay? I don't know if you want some Germany, but come on. It's good. But this is also the European Union investments. You know why? Because the phase out of coal, because do a lot of emissions. So you're going to transfer the energy here. So they invest in incineration. So Poland is going great in incineration. Although now European Union is not happy with this result. And you can ask why, because they invested here. Why they are not? Because now they change the policy again and they say incineration is not good, there's too many emissions. So now you need to cap the chimneys of the incineration factories with some kind of technology. You Poland solve it because you are polluting too much. So now Poland has to invest tax Poland money to put up the caps on the chimneys. So this is kind of a, as you see, this is kind of a living organism that deal with this construction. And I find this amazing. And this is not my topic. And this is how COVID was impacting Poland. Very amazed. This is the things that I already said, because I'm not following my script anyway. It's just for you. And okay, and yeah, I told you the rates are great. You are reaching these. I made this from, I don't know if you saw it, from 18 to 22. I really put the effort on me. And I can tell you that in 22, and I think went by there, Poland is coping with the European Union. So you are a good learner. You have your own things, but I think you have, well, you will find a way to solve it because you are doing well. Okay, thank you so much. Can go.
Thanks to all presenters. You guys did a wonderful job, and we have 10 minutes left, a little less than 10. So, Professor Koda, we should open floor to questions. We have a microphone ready if, thank you. So if anybody has questions to any of the speakers.
Comments and opinions.
Yeah. If nobody has, I could start opening a question. Krishna, go ahead.
No, I just want to give
They need microphone.
kind of a general comment, and then maybe we can have a discussion on it. So in the solid waste management area, everybody talks about this pyramid, right? And we emphasize prevention, minimization, recycling, reuse, and at the end you go for landfilling. But these days, people are saying dump that hierarchy because it doesn't work. So let's say you want to do recycling. Okay, you did a lot of recycling, but when there are no markets for recycling, what are you going to do it, right? So in the U.S., we used to do a lot of recycling, and we used to ship those to China and Philippines and other places, and they started not taking it because a lot of recycled materials that we were sending, they're contaminated. They're contaminated because Americans were very concerned about recycling, and they would put the things that are not recyclable in recycling bin, so the entire recycling bin becomes so useless. So people have to know exactly what is recycled, what is not recyclable. And then as a result of that, because we don't have markets, so we cannot really ship our recycled materials to China and other places, and a lot of recycling places have closed. They don't know what to do. If you have a lot of piles of recycled materials, what do you do with that? So the strategy, I think, now instead of this hierarchy, the best strategy to look at waste management is integrated waste management, not this hierarchy. So in the integrated waste management, you need to consider all of them, like resource recovery, basically, recover the materials, or recycle, and all those things have to be done. But don't emphasize that hierarchy in a universal way. You really have to look at, situation specific, right? So we call it life cycle assessment, right? You can simulate a scenario, you can create scenarios of how much, of each of components of that waste management strategy you have to do it, so that you can have a net, impact, right? So both, environmentally, economically, and socially. And then each place, let's say if Warsaw is there, you can run that analysis for Warsaw and find out what is the best combination of these integrated waste management elements that you can actually incorporate to make the sustainable waste management in Warsaw. And I cannot do the same thing for Chicago. And Chicago has its own, waste management strategy. So that's, thinking that has to go, instead of hierarchy, we need to look at the integrated way and doing the life cycle assessment of, what is the best strategy. That's one thing. Another thing that I wanted to mention is, in all these waste management strategies, socio-economic factors is the most governing factor, socio-economic factors. Because, if you don't impose, for example, I tell you, in my neighborhood, we pay tax every year for the solid waste management. So every week when waste people comes to collect the luggage, we can put as many bags as we want. One is recyclable, the other one is non-recyclable, and we are not mandated to recycle, but it's up to individual. And we can put as many bags as we want because we pay the fixed tax for whole year. But my next suburb, they don't tax at all for the year. They don't tax lump sum, but they tax every bag they dispose of. You really have to put a sticker. You have to go to the grocery store, buy the sticker, and you have to put the sticker onto the grocery bag, the garbage bag, and put it on the curbside. They will come and pick it up. Guess what happens? My neighborhood, residents don't care how many bags you put it in, right? I put 10 bags. But I go to the neighborhood thing because they have to put like one tag on each one. They try to put, they try to reduce as much as possible, and they put like one bag outside. So they're reducing. These socio-economic factors, if you impose the tax or, create some mechanism to force people to think, if it's monetary-wise. I think that's kind of a general comment I wanted to make it because there's a lot of debates going on, a lot of things are happening. On the ground, not much is happening. And people say zero landfills. I mean, that's fine, zero landfills is fine. But, what is happening to the waste even if you don't have landfill? So it's ending up in the streets, right? So that's...
Can we stop that and maybe somebody wants to comment on that? Or, yeah, Magdalena, yes.
Shortly. Thank you very much. Already, I absolutely agree, but there are two things, that what we do, we don't do recycling at home. We separate our waste, and somebody should do the recycling. Yeah, so this is one thing. And the other, as you said, I think we lost the connection with the environment. We don't feel it. Somebody will come and will do it, and I don't care. And I think in Japan, I spent quite a long time, I realized they are back to that. You know, they feel it. It's our environment. And not that somebody will clean it for us, not that somebody will take care, but we do it. We will do it. So I think this is the lesson. And yeah, thank you.
Can I add a question to you, Magdalena? Is about, you showed the pictures of waste around the world, and my question is, every country does their own thing, and clearly nobody's doing perfect anything. So just like we have regulations from United Nations for missile proliferations, about wars and chemical weapons, is there any regulations in the United Nations pipeline, or somebody's thinking that should mandate a lot of countries to do certain things with their waste? Otherwise, as you said, waste has no boundaries. Just like weapons have no boundaries, if you don't restrict it, they can go across the boundaries. So why is the waste not treated like weapons in a way, in terms of regulations?
There's also a black market, you know, and as you said, Germany is selling waste to Poland, and in Poland we are not putting it to incineration, but there are accidental fires, landfill fires, which were more than 800, I think, last few years. So, yeah, so the incineration, I think, unfortunately, is our future, because there is no other way to.
The incineration factory is charged by the emissions. Maybe they want to go around. You know that during this research, I also come across, as you mentioned, there was this huge fire of tires in Kuwait. I don't know if you heard. All the time, yeah. So I know there is some criminal activities, because you know the problem is also from the government, because if you tax people so much, people will discover a way to trying to bypass the system, and when people bypass the system, it's worse than, you know, some system. So, and I think can address your comments. So this is the problem. If you tax too much and you impose so much problem, people will solve it in an easy way, and the easy way is burn it, you know, hide it. So, and it's solved.
So yeah, somebody there.
Thank you, Professor Nuno. I just want to add one small comment. It's not only about we try to recycle waste materials. We don't have an end market. We are putting extra energy into it, and then we are storing it somewhere. So it's more complicated situation. Like I did a study in Abu Dhabi last year. The waste contribution in solid is approximately 70% in Abu Dhabi and UAE. It's highest in the world, 70 to 75%. And the problem is we have all the type of waste management plans. The end material is ready, but no one is ready to use it, because either of the quality, either of the price, number of factors. So what they did, they are recycling 100% waste, and now they have a new inventory that needs extra space, extra energy, and extra money. So this, we are not even looking the life cycle to close the loop. We are actually creating a new issues and challenges for the environment. And same with all the, I think I have attended a number of conferences, and whenever I ask, okay, you have an end market for your new recycled material? They were like, yeah, we are exploring. There are things. There is no concrete answer I have, till date, I have received from anywhere. And I think as a community, we should first find out a new end market, then we start processing this waste. Otherwise, there is of no use. It's just gonna waste of money, waste of resources, waste of energy, and more pile and more pile and more pile. And for that, the catalyst should be government, because we as researchers, we can try to put this topic in different forms, but until unless the main stakeholder, the major stakeholder, government, in their policies mandate it, like, okay guys, if you are going to construct a new building, you have to use 50% of the waste materials or recycled materials. Until unless, I don't see there is a future. Thank you.
Any other comments? We may have one last question and then we'll close the session. Somebody in the back there, did you raise, please raise your hand if you, yes, go ahead.
Thank you for voice. I have one question, because one of the presentation is about segregation of the waste in the building site, and who have to be responsible for the segregation on the countryside? The site manager or the waste company who get to collect the waste? This is the problem, because nowadays you put everything in one bin. There is a problem because concrete, plastics, everything you have on the construction site goes to the one bin, and it goes mostly on the waste storage. And there is no law regulation who care about segregation on the building site to segregate the waste.
Thank you. Well, thank you, everybody. Is there somebody wants to respond? Yes. No? Everybody good? All right. Well, thank you, everyone, for attending the session. Let's give a...
Can I say what?
Yes, please.
Please.
Sorry.
Okay. That's
connected. So I will give it to you. But I hate to end up a conversation with negative ideas only.
Yeah.
So let me just give you some inputs. And I think I have 2 inputs here. This is, if we don't take care about this problem, we have, maybe we have a solution that we run out of primary materials, so we need to look up the recycled ones, because there are no materials anymore in the earth. So we need to take out of the, in the instant, recycled material is going to be gold, because there's no materials on the earth anymore. But I would like, because there are many PhD students here, and probably will be more in the future, if everything goes according with the plan, you also can look to these things and try to solve the issue before the issue solves itself. So why not look into waste and try to see if you can pull out some economy from it? And maybe by pulling that, you can solve a problem, and maybe you have a great career by solving this problem. Thank you.
As you said, from the economics point of view, if I have money and if I'm going to live 1,000 years, I will buy all the landfills in the world. Yes. Because you have to put a lot of resources there. You're going to run out of all the materials, so you're going to go there.
Speak to the microphone. We finished.
I just hesitate to ask a question, because my question is particular to you actually. So discussion goes to the general things. May I ask this particular question, engineering question?
Sure.
Okay.
Yes, go ahead.
So you were saying about the composition of material, okay? And have you tried to make the state of material? Because, well, the materials are actual mechanical behavior depends on the composition and the state of material, okay? You were representing the composition part, let's say. And therefore, I just want to ask if, well, because you mentioned that you are at the first stage actually of this research, so it's I am curious if you try to do it for different states, and especially I'm interested in how it influences the stiffness of a soil, because when we speaking about improving, we think about the stiffness and the shear strength.
As a matter of fact, we do have some. I did not show some of the figures. I did not show some of the figures. We have started the investigation. So I mean, it's off the topic. I can show some of those offline if you'd like. But the impact on the stiffness was under one of the parameters under consideration. So it's just, that's the tip of the iceberg. There's a lot of other numbers that I haven't shown, and there's a lot of other things that we have in mind. But any feedback would be interesting as well to consider, because you think you have considered some of the stuff, but then depending on the resources, but then in the future we're working with the sponsor for the long run, and we're not the only one, but any feedback would be interesting. But yes, we do consider some of the parameters and the state as well. And as I mentioned, it's not only the parameters and the stiffness, also the impact of the temperature, because the environment, there are temperature, high desert arid areas impact the temperature, precipitation, and a lot of things. And the leachate, this was just a leachate test. of the affluent of hydraulic conductivity test. There's a lot of the other things to be considered. Yes.
Any other questions? No. I don't want to rush. Boom. Coffee.
Please, just a moment. Please, and Magdalena
And we want all the speakers after that to take a photo of all the speakers too here.
This meeting is being recorded.
Good morning.
This meeting is being recorded.
Good morning, everyone. Today, I'm here.
This meeting is being recorded. This meeting is being recorded.
So, ladies and gentlemen, we are with, well, I don't know how to address, professor, I will call it, Marco Rosani, will present a preliminary investigation on the use of marble factory by projects as a sustainable soil stabilizer. You can start, Marco. As soon as Maurits leaves the computer.
And the presentation. Okay. Oops. I want to use the pointers. No pointer. Okay, thank you so much. Good afternoon, ladies and gentlemen. I have to share the preliminary results of a research project financed by Italian Ministry of Research from Italy, founded with founded with European funds, about the soil stabilization with innovative and sustainable binders. The ornamental stone industry has a great impact on the economy and the environment worldwide. You can see the world gross stone production and the worldwide turnover in the years, and we see the trend is increasing in the future. The top producers in the world are China, India, Turkey, Brazil, Iran, and Italy. But mining and quarrying sector are second after construction industry for waste generation. In 2020, the gross quarry production was 318 million of tons, but 71% was waste from extraction and processing procedure. Waste can be classified in solids and sludge, while the solids, the recovery and the recycling procedure for solids is well consolidated, but for the sludge, actually today these are disposed in landfill. So the aim of this research is to explore the possibility of improving the sustainability of clay soil stabilization for general infrastructure, for example, construction embankment, using a new chemical binder derived from sludge waste. The marble slurry come from Custonaci quarry, which is located in Sicily, in Italy. It's a well-consolidated marble used for ancient and recent buildings. We can see some application. Every year in Custonaci, Trapani, Sicily, 200,000 tons per year are produced. So we want to try to convert this waste in a sustainable chemical binder by two methods. The first one, the calcination, and the alkyl activation. Today I will speak about calcination. In this slide, I reported in the first step the conversion process we studied, starting from as received material in the lab, the marble slurry. We dried at the laboratory condition, crushed and sieved the material, and after kilning, we obtained a material basically constituted by calcium oxide, and we produced the calcinide marble powder, CMP. The process direction mechanism between clay, water, and calcium oxide is well consolidated, starting from mixing, then compaction. The first reaction process is the dehydration calcium oxide, and after, with the correct environment, alkaline environment characterized by pH 12.4, we have the cation exchange process in the short terms, and the pozzolanic reaction in the long term. At the end, we have the stabilized clay. The clay we used is recovered from a landfill construction close Trapani, close the quarry. And here you can see some pictures of the construction site and the properties of the materials in terms of mineralogy and particle site density and plasticity. We start with test of affinity. The pH measurement and Atterberg limits are represented here. We can see that increasing the NCFP content, the pH increased to 12.4, and the plasticity index reduced. So we fixed the initial consumption of binder equal to 2.5%, which is the content which ensures the correct environment to produce pozzolanic reaction. So starting from this content, we study the compaction properties for 1.5 and 2 times the CMP content, the ICB content. At the same time, we performed the same test on an industrial quicklime, and we obtained the same properties with an increased content because the ICB was fixed at 3%. Here I represent a microstructure investigation carried out by means mercury intrusion porosimetry test. We see that the microstructure is characterized by 2 levels of porosity, micropores inside aggregates and macropore between aggregates. And at time 0, the swelling behavior is reduced by the treatment. Here we can see the results of the confining compression test carried out on the 3 different mixtures. We see the results in terms of axial stress and axial deformation, axial strain for the different time we investigated, 0, 7, 14, and 28 days. We see an increasing strength and the stiffness increase and the high peak of stress at failure. Here we can see the comparison between the results obtained with the CMP on the left and the quicklime on the right. We have quite similar results in terms of confined compression strength, which yes, with failure obtained also at value around 1 MPa. Here we can see the results in terms of stiffness, Young modulus, and also here we can see quite similar results. We monitored the water content, the total suction during curing, and we see that for us, as effect of the pozzolanic reaction, we have a consumption of water, and at the same time, the total suction increase. So we need, and the same processes was observed for the quicklime stabilization. So we think that we need more tests to investigate the coupling between the hydromechanical behavior and the chemical process activated by the treatment. In conclusion, this study investigated the potential of marble slurry, a byproduct for marble industry, as a new herbicide chemical additive to stabilize clay soils for infrastructure application. A first marble slurry conversion process by calcination was investigated. Preliminary experimental results showed that the CMP induces significant modification in the behavior of clays in terms of plasticity, compaction, microstructure, swelling, and strength. CMP requires lower dosages than quicklime to trigger cation exchange and pozzolanic processes. Further investigation are required to evaluate the long-term behavior in terms of hydromechanical behavior, response to cycles of wetting and drying, of freeze-thaw, response, and the microstructural change, and the environmental implication like CO2 emission by means of LCA application, for example. A second conversion process by alkaline activation of marble slurry will be investigated. I report on the end the website of our project. I will be happy to share with you our information, and I will be happy to have your feedback about the results. Thank you very much.
Thank you so much, Mark. We can open for a question or two. Anyone wants to? Marco, come. Please stay with us a little bit more. Anyone has a question for Mark? So I would like to pose one. And my question is, in this research, because you are collecting materials and you are presenting that marble site, is there any kind of economic partner involved with your research that can apply this in the future?
Funding became from public Ministry of Research from Italy. We want to involve the construction site for the
industries.
The industries, yes, obviously, yes. We're trying, but it's very difficult. We will try again.
Thank you, Mark. Anyone wants to make a question? So, okay, Mark, thank you so much.
Thank you, Marco. And the Second speaker for today is Atif Hussain, who's going to present a paper titled Investigation of Shear Behavior of Tire Chips, Intermixed Steel Slag Ballast Under Direct Shear Condition. You've got 10 minutes.
So, good afternoon, everyone. I'm Atif Hussain from India, and my topic is investigation of shear behavior of tire chips intermixed steel slag blast under direct shear condition. As we all know that rail track is a fundamental part of railway infrastructure, and its component mainly classified into two main categories, that is superstructure and substructure. As we can see from the figure that superstructure basically consists of rail, sleepers and fastener, while the substructure consists of ballast, subballast and subgrade. And to ensure safety and comfort to the passenger, both the superstructure and substructure are equally important. Of the various components of substructure, blast plays a vital role in transferring load from sleepers to a larger area formation, and the cross-section view of the railway track can be seen, and the blast depth usually adopted in across the globe ranges between 250 to 350 mm. So let us discuss the various types of blast material used across the globe. So depending upon the availability and the type of loading coming onto the track, the blast materials basically comes from the natural mountains, and these are basically classified into granite, basalt and limestone. The view of the different types of blast material can be seen here. So the main problem of is the rapid urbanization, and the growing population increases the demand of railway transportation. As we can see, the increase in the demand of railway transportation increases the demand of railway blast, and so the affect the economy as well as the environmental perspective. It has been reported that Indian Railways procured around 8 million cubic meter of blast that cost around 140 million US dollar. Therefore, there is a need to search for an alternative materials. So let us discuss the alternative material that is that can be used as a blast material. So the steel slag basically is an industrial waste product generated during the steel making process, and the different types of steel slags are basic oxygen furnace slag and electric arc furnace slag and ladle furnace slag, depending upon the type of furnace used in the production of steel. So we can see that the Japan, US and Australia and other European countries utilizes almost all of their steel slag produced in various construction activities, but India utilizes only 25% of its total steel slag produced, and it is also anticipated that India is going to produce approx 25 to 30 million tons of steel slag annually by the year 2030. Therefore, there is a need to efficiently utilize the steel slag, as its disposal not only occupies a larger area of land but also poses challenges to environmental and human health. So the main problem of utilizing steel slag is its higher stiffness. So the higher stiffness may lead to affect the track components like sleepers and fasteners and rails. Therefore, there is a need to mix the steel slag with the rubber materials. So the rubber materials can be mixed in different forms depending when it is mixed with the binding materials and used under the sleeper. It is called readily bound ballast, and when coated using binder, this is called RCB or rubber coated blast, and when used as a mat or sleeper pad. And another way of using rubber is crushing the rubber in chips form, and can be mixed with the ballast. So coming to the objective of the research, the first objective is to evaluate the shear strength of steel slag and granite blast, and the second one is to assess the influence of tire chips that is mixed with the blast on the shear characteristics of steel slag and granite blast. The third one is to optimize the proportion of tire chips based on the performance on direct shear test. So coming to the material used in the present study, the granite blast used and this processed and weathered steel slag used, and the tire chips and the particle size distribution is adopted as per Indian Railway standard. So the static direct shear test is conducted to achieve the objective. The large scale direct shear test can be seen here from the figure, and the schematic view of the direct shear apparatus can be seen here, and it is basically the 450 to 450 square box, and upper box was free to displace by maximum amount of 100 and while the lower box is kept fixed. So coming to the results, it can be seen from the figure that Los Angeles abrasion and impact value of steel slag blast was found to be lower than that of granite blasts, and also it can be seen that with the increase in the proportion of tire chips, both the Los Angeles abrasion and impact value of both the materials, whether it is steel slag and granite, decreases. Also, the direct shear test results, it can be seen the direct shear test result that the peak value of shear stress of steel slag blast was found to be higher than that of granite blast. This is due to the higher angularity and surface texture of steel slag compared to granite blast. Also, with the increase in the proportion of tire chips, the peak shear stress of both the steel slag and granite blast reduces. However, when the proportion of tire chips increases beyond 4.4%, when the normal stress is 50 kilopascal, the shear strength of steel slag blast becomes lower than that of granite blast. So in this perspective, we can say that a proportion of 4.4 to 9.2% of tire chips can be mixed only with the steel slag blast. From the it is obvious that when the normal stress is applied on the direct shear in direct shear, then the blast obviously it breaks. So it is defined, it is basically evaluated in the form of blast breakage index, and it is seen that with the increase in the proportion of tire chips, the blast breakage index of both the materials reduces. However, the steel slag which has higher specific gravities, it is heavier, obvious because of the iron content, so it shows lower breakage compared to granite. Now coming to the conclusion, it can be seen that Los Angeles abrasion and impact value of steel slag and was found to be lower than that of granite, and addition of tire chips reduces the Los Angeles abrasion by and impact value by 38% and 32% respectively, and the direct shear test results signify that the peak value of shear stress and blast breakage index was found to be lower than that of granite blast, and with the increase in the proportion of tire chips, the breakage and shear strength of both the materials, steel slag or granite, reduces, and based on the shear strength, the 4.4 to 9.2% has been adopted as the optimum percent, depending on the quantum of axial load coming onto the track. So the my other works include the shear behavior of slag granite mixtures, which are evaluated under direct shear conditions, and the cyclic performance of slag granite mixtures were also assessed using large scale triaxial testing apparatus, and the optimum content was evaluated to be 60%. And it is yet to be evaluate the behavior of a tire chips intermixed slag granite mixture under a cyclic condition, and the permeability of tire chips intermixed slag granite mixture under clean and cold fault condition. So these are the references. Thank you.
Thank you, Ati. Very topical presentations. Rail is probably one of the most sustainable ways of transport for the public. Are there any questions? Okay, yes, please. Can we have a microphone there? Or? Yeah. I can just speak loudly.
Thank you for your nice presentation. I was just wondering, do you know if the proportion Hola. Maybe now? Yeah? Okay. Do you have any idea if the proportion of tire chips does affect the instability of steel slag with moisture content? Have you looked into it?
No, this is beyond the scope.
Okay.
But
was
that's
just
why
wondering.
we kept the percentage limited, this 4.4 to 9.2%. That may affect in another perspective.
Okay.
So we have limited the percentage, the tire chips
Okay.
proportion.
Okay.
Up to
Okay.
9% or 10%.
But you haven't specifically
No,
looked
in
at
the presence of moisture, I've not conducted the test.
Okay. Okay. Thank you.
Thank you. And one more question.
So in steel slag in India, so due to that pre-lime content, so volumetric expansion is there in most of the steel slugs available in India. So have you checked the volumetric expansion?
Yeah, I have conducted the volume expansion test for unaged and 6 months aged and 1 years of aged, and I found that the unaged have expansion more than the prescribed limit from by ASTM, and this is I found approximate 3.5%. I found unaged, and after 6 months I found the below the prescribed limit, that is 0.5% as prescribed by ASTM. And that's why I have used the materials which is aged for 6 months.
The material in the laboratory
Yeah.
at a higher temperature of around 72 degree, I think.
Yeah.
So within 7 days you will get the result
Yes.
of that expansion instead of waiting for 6 months the testing period in laboratory, that you can test the volumetric expansion within the limit or not.
Okay, I would suggest to finish that conversation over the coffee. We are running a little bit behind.
Okay.
Yeah,
so we
we'll
will
discuss.
invite the. Yeah.
Thank you.
Thank you so much. I don't know if this is working or not, but okay. We're gonna have Miss. I think it's a Miss. Sorry, Diva. It's a Miss, right? And she's gonna address us in sustainable binder for deep soil mixed columns in loose sand. Oh, you just saved my day. Thank you. Oh, you are Miga. Okay. But Diva, I think, is also okay. Go, Miga.
Good evening, everyone. I am Megha Shankar. I'm an MTech student from IIT Palakkad, and I'm working under Dr. P.V. Divya. And my topic for research topic is sustainable binders for deep soil mixing columns in loose sand. So these days, due to the population explosion, there is a very huge demand for transforming the unsuitable land for the construction purposes. So among the problematic soils, one among the problematic soils is loose sand. And the problems regarding loose sand is first liquefaction, and then the next one is large settlement. Hence, there is a need for ground improvement for loose sands. There are various techniques for ground improvement, like vibroflotation, chemical stabilization, etc. And here I am using, I'm more focusing on deep soil mixing. The deep soil mixing method, it's an in situ treatment in which the native soils are blended with the cementitious or any other materials which is referred to as binders. Generally, using this deep soil mixing columns, we can improve the soil's slope stability, reduce the settlement, increase the bearing capacity, and also provide lateral support. The conventional binders which we use for this deep soil mixing method is cement and lime, but these also has disadvantages, such as they both have high carbon emission and also its natural material extraction and exhaustion. Hence, there is a need for sustainable binders. Sheena and Divya and Mansi and Divya, there were two papers reported that the application of a sustainable binder for ground improvement using eggshell lime and rice husk ash in both clay and sand. And it was found that the optimum ratio for eggshell lime is to RHA, that's rice husk ash, was found to be 5:10 for granular and 3:9 for clay. So in my experiment, I have taken, since it's sand, granular material, I have taken 5:10 ratio, and the materials is sand, which is classified as poorly graded. Then we have ricer's cash, RHA, which is the outer covering of rice. And then we have eggshell lime, which is calcinated eggshell. The eggshells were collected, grinded, sieved, and then calcinated at 1000 degrees Celsius for 1 hour. And then first we did a strength test. So 110 gram of soil were taken, and 5% of eggshell lime was taken, and 10% of RHA. And initially we used a water content of 18%, and a curing was done for 28 days. So from the result, we could see that the UCS value was 2542.2 kilonewton per meter square. Then we have done the hydraulic integrity test to check if the binder is stable underwater. So a part of this UCS broken sample was submerged in water for 30 days. And after 30 days, it was seen that the sample remained intact, hard and strong, and no binder was washed away. Since it's sand, we need to know the molding water content. So 3 samples at each water content, 15%, 18%, and 21% were prepared. And we could see that from the graph, the 7-day UCS graph, it could be seen that 18% water content yields the highest strength. Next, the effect of curing was also found. So we have taken 2 types. One is desiccator curing and the other is air curing. So in case of desiccator curing, on the left hand side, you can see that from 7-day curing to 28 days curing, the strength has increased from 1200 to 2542 in the case of 18%, since that's the highest in both the graphs. But in case of air curing, you can see that the strength has reduced from, with the more number of days, from 7 to 28, the strength has reduced from 834 to 500. So this could be due to the CSH gel which is formed here is actually, there is a degradation when it comes in contact with the carbon dioxide in the air. So there are 2 types. The figure shows the CSH gel structure. So we have 2 types of calcium ions, which is interlayer and intralayer. So first, the interlayer calcium ions get decalcination process happens, and then the intralayer. So as decalcification occurs, the CSH molecule structure continuously deteriorates. Also, the water content in these air-dried samples were also checked, and we could see that with the increase in number of days in all the water contents, the water content ratio has decreased. And we have done a scanning electron microscopy test in which we could see that a flocculated structure is formed, and this indicates the presence of a newly formed CSH gel. So the conclusions from this study is the binder was able to impart binding properties in sand particles. The UCS test shows the maximum compressive strength obtained is 2542.2 kilonewton per meter square. The optimum molding water content was found to be 18%. The SEM images confirms that the binder addition results in the CSH gel formation, and also the sample integrity was maintained in submerged water. The desiccator cured samples gave a higher strength when compared to air curing samples. These are the references. Thank you.
Okay, thank you so much, Megha. Okay, anyone have questions for Megha? Okay, I have one. What's when you made this research? What was the main applications of this technology? Let's call it. So, what kind of economies or economy field can serve best this kind of technology and this approach, of course?
Yeah, actually recently, like all these days, we have been using cement as mostly the binder. So in cement, CSH gel is formed. So we were trying to get the same CSH gel from the waste materials. So this RHA and eggshell lime are both waste materials which can be found anywhere. So that
The idea is to reduce cement production.
like the same CSA gel is formed but without the cement, using the waste material.
Okay, sounds good. Thank you. Okay.
Megha, thank you very much for this lovely presentation. I have a very small comment. I'm a project manager and I look as the perspective of feasibility. So you have replaced here your calcium contents and cement with your binders. Is it feasible to find those binders? Because it needs a very much amount of labor and technology, because eggshells, first you have to crush them, then you have to sieve them, then you have to have a very specific ratio. And secondly, have you done any cost analysis between both the techniques? Because ultimately it's gonna be a same question, end user. If that thing is not feasible, no one is going to use it.
So it depends on the place also. Like I'm from Kerala, and in Kerala we have a large rice production, so we have plenty of rice as cash available, and also eggshells are also very easily available there. And I have done the life cycle assessment, and when compared to cement, we have got 77% reduced effect on the environment. The cost analysis I haven't still done yet.
Factor would be cost. You please look into this also.
Yeah, sure,
Thank you.
sir. Thank you.
Thank you very much. Is it on? Is it on? Is it on? I would like to invite the fourth speaker for this afternoon, Preeti Maheshwari. Sorry for mispronouncing. Who will present the paper titled Response of Double-Line Railway Track Reinforced with Stone Column Using Finite Element Method. 10 minutes.
Very good evening to all of you. I hope I am audible without the mic. No? Okay.
We actually are transmitting the whole session, so please use the microphone.
Okay, fine.
You have to see the light. Put it on.
Okay.
Okay, now it's on.
Very good evening. I am Preeti Maheshwari. I am from Indian Institute of Technology, Roorkee. I am professor in the Geotechnical Engineering group, and the work that I am going to present in front of you is the work of one of my doctoral student, Mr. Shubham Khatri, who could not come, so I am here to present our work. We have been talking about the sustainable infrastructure and sustainability and many such aspects since morning. So here is a little bit different kind of a work because, as the infrastructure development takes place, we may not get always a ground which will provide the foundation a very good load carrying capacity. Okay, so in that case, we need to go for some of the ground improvement technique, and you all know that the provision of stone columns is one of the quite widely adopted ground improvement techniques. So using that, I am going to present here an analysis for the response of double line railway track, which is reinforced with stone column. This is a hardcore numerical analysis. So this is going to be the overview of my presentation. I will not go much into the mathematics. Details can be found in the paper. So let me directly go to the introduction. So this is how a double line track, railway line track looks like. And not many studies have been conducted to understand the behavior of this type of track, especially on the when these are laid on the reinforced ground. So, and then this is like figure, those who are working in the ground improvement area, this figure is like very well known. This is how we construct these stone columns. So we have been working for many years. We have handled the problems related to the single track. So this is how that typical model that we have been working with. It is not the continuum modeling or the finite element modeling. It is the lumped parameter modeling that we handle, but for single track. So coming to the modeling and analysis part of the present work. So first of all, we modeled the system, the ground and the embankment without the stone column, and a typical finite element model looks like this, as shown in this slide. And so here, after discretizing, the mesh looks like this. Again, all the details, what all were the mesh and how the convergence study and all those things, they are available in the paper. You can take a look later. So then for the analysis, we use this software Abacus. And these were the input parameters and the constitutive models which were used for the different parts of the track system, that is subgrade, ballast, sub-ballast, sleeper and the rail. And the loading configuration is shown in the figure below. It's a typical loading configuration that we adopted. I will come to the runs and the results little later, but then after doing this simple ground without reinforcement, then we install the stone columns, and the model looks like this. It is a 3D model that we adopted, and the finite element mesh for the complete system with the stone column, it looks like this. Now coming to the some of the results. So before we went for the detailed parametric study to understand the effect of various input parameters, we just tried to see whether our model is working fine or not. So for that, we took the help of some of the earlier studies which have been published without the reinforcement. So we could get a reference point that, okay, if everything is fine with the model. So we could see, if you see the red and the black color plots here. So these are, one is red color, one is from our study, and the black color one is from the earlier study. And then in this figure, so I showed you that we have modeled with the stone column. So in this figure, we superimpose the results that we obtained for the response in terms of the settlement versus time when the ground was reinforced with stone column. And then you can see clearly how the settlement is reduced with the inclusion of these stone columns. So although this is very obvious conclusion, but the important part is we are able to quantify that, okay, it is going to be reduced by this much percentage. Then we carried out the parametric study, detailed parametric study. So here, like, we varied the load for some input parameters which are mentioned here. V is the velocity of the load, S by D is the center to center spacing to diameter ratio of these stone columns. L is the length or the extent of the stone column in the vertical direction. And you can see that with stone column how the maximum settlement is reducing. So actually this is really helping us in reducing the settlement of the, or settlement below the track. Then we saw, because velocity is a very, very important aspect as far as the railway tracks are concerned, and you can see that after about 350 km per hour, the settlement or the response remains almost the same, even when we increase the velocity. So that's what that we defined as the critical velocity. So for this particular case, we obtained the critical velocity about 350 km per hour. Then we changed the, or we varied the elastic modulus of these stone columns, but we could not see much difference on the settlement as evident from these two figures. Then we varied the extent of these stone columns. So we varied it from 4 meter to 10 meters, and you can see the result. And one thing I would like you to note, that when we extend the length of the stone column beyond 8 meters, of course, for a particular set of input parameters, then the reduction in the settlement is not that much. Then spacing to diameter ratio, and we can see that about 3.5 to 4.5 we can consider it to be the optimum S by D ratio for these stone columns. Then we also carried out the sensitivity analysis for various parameters, and you can see here that load is the parameter to which the response is the most sensitive, and followed by the spacing to diameter ratio of the stone columns. So yeah, I'm well in time, so thanks. The major conclusion that we drew from this study was like, of course, as I mentioned, as expected, stone columns are useful in restricting the settlement to some extent, and in our case we found that it can be as high as 40%. And we could get that the critical length of these stone columns was of the order of 8 meter. Then the significant influence of stone column stiffness was there only for the very soft subgrade. And from the sensitivity analysis, we saw that the applied load and spacing to diameter ratio, they significantly influence the response. Right now we took a very simple case, but the work is in progress, so where we are going to deal with, let us say, the train on both the tracks in opposite direction with different velocities, and also that work is ongoing. So this is what that I have to discuss with you today. Very thanks for your patient hearing. Thank you.
Thank you, Preeti. Thank you for staying within your time frames. Very interesting presentation. It's great how numerical modeling allows us to do so many different variations of the design. For benefit of time, we will try to go with one question from the audience. No question from audience, which is a good news for me because I can ask them my question. In terms of the validation, I noticed that you validated your model against the non-improved case, but was there an improvement case validation run as well?
Actually, no. Actually, to the best of our knowledge, till now, this with the improved soil and double track, people have not carried out any analysis. So basically, we could not get any study to, validate our work. But then, because we did it with the help of this particular study for unreinforced soil, unreinforced ground, and also we are trying to validate it with some of the experimental work or the field study, again on unreinforced ground, because that is what is available to us. So that's the problem.
Thank you.
Okay, so let's proceed. Now we'll call Nakib. Oh, it's you. So we'll present behavior of clay, folded geogrid reinforced rubber, coat blasted under direct shear conditions. Huge. Okay, Nakib, you have the stage.
A very good evening, all of you. I am MD Nakib Alam from IIT Patna, India. Today my presentation topic is behavior of clay folded geogrid reinforced rubber coated ballast under direct shear conditions. These are the contents of the present study. This is the basic figures of railway ballasted track, BZ track, showing the various component of the track, which is divided in two parts: superstructure and substructure. Rail ballast, rail fasteners and sleeper in superstructures. Ballast, subballast, and subgrade are in consist of substructures. In these all components, ballast plays a very important role. It holds the sleepers during the passage of train, and it transfers the load from wheel to the subgrade layer, and it also provides adequate drainage also. Coming to the problem statement of the study, we have considered, we know that in the last 2 decades, the use of automobiles increases around the world exponentially. Due to increase in automobiles, huge numbers of waste tires will be generated. The major problem is it is very difficult to how it will manage economically, and both it is generally it is discarded in landfills and stockpiles. So to overcome these problems, to minimize, we can use these waste tires as an elastic element in a railway track for improving the performance, to reducing the ground-borne vibrations and the ballast degradations by using these elastic element in different forms, just like under sleeper pads, under ballast mat, and then rubber coated ballast, and mixing with the ballast. My colleagues have presented tire chips is mixed with the ballast. Coming to the rubber coated ballast, this is nothing but a new inventive ballast aggregate. Coating consists of natural aggregate coated with the recycled chrome rubber with the help of polythene binder. This is the figure showing the rubber coated ballast sample. This innovative ballasts have aimed to reduce the ground-borne vibration within the track, and also reduces the rate of degradation of the ballast layer. That's why we have reducing the frequent replacement of the ballast, and it also increases the energy dissipations due to the rubber particles surrounding to the ballast stone. Field studies conducted by COMSA Corporation in June 2019 in Spain, they have found that when in rubber coated ballast section, the ground significantly amount of ground vibrations is reduces as compared to conventional ballasted track. These are the some literatures. We know that the falling material highly influences the performance of ballasted track. That will reduces the blast drainage property and shear strength deformations, and that ultimately reduce misalignment that railway track. Then in this context, various researchers have investigated the effect of falling on the performance of ballasted track. These are the some literatures. Coming to the objective, the first objective is to examine the physical and mechanical properties of rubber coated ballast, conventional ballast mix. And the second objective is to examine the shear behavior of unreinforced and geogrid reinforced conventional ballast RCB mix under different void contaminated index VCI. These are the materials which is used in this for conducting the test. Fresh granite ballast, chrome rubber of size 0.4 mm for preparing the RCB sample, elastin polythene binder to gluing the chrome rubber over the natural aggregate, triangular aperture size geogrid. The falling material is which is used plastic clay, medium plastic clay. This is the grain size characteristic of clay fines and the ballast. The ballast gradation is chosen as per the Indian standards, within the limit of Indian standards. Coming to the testing procedure, the physical and mechanical test we have conducted according to Indian standards. After that, a large scale direct shear test have conducted in with and without geogrid in 3 all samples. The normal stresses we have taken 40, 130 and 195 kPa, and the falling content is 0, 20, 35 and 50. For geogrid reinforced ballast, a layer of geogrid is inserted at the interface of upper and lower box of the direct shear. In case of clay folded ballast, we have mixed the predetermined amount of clay. This is the photograph showing the testing procedure for geogrid reinforced clay folded rubber coated ballast. First of all, we are mixing the predetermined amount of clay with the rubber coated ballast with the help of concrete mixture. After that, we have put in the lower box, and after that we have placed at the interface of 2 boxes a layer of geogrid, and after filling the upper box, we have ready to test. This is the result showing the physical and mechanical properties of different samples of ballast. From figure A, it is seen that the water absorption value of, in case of rubber coated ballast, is slightly less as compared to other samples, because in rubber coated ballast samples all the pores are tightly packed with the rubber coating. From figure B to E, it is seen that in case of rubber coated ballast sample having very less value of abrasion and impact and weathering resistance, that is soundness value, it means that rubber coated ballast sample have higher resistance against crushing, abrasion and impact and the weathering. Coming to the results of direct shear test, from figure A, it is seen that as the normal stress increases, the peak shear stress is increases. In case of we have also seen that in case of in case of rubber coated ballast sample, due to poor interlocking properties of rubber coated ballast sample, have less shear strength. When we have reinforced with geogrid, the shear strength is increases. From figure B, it is seen that the peak shear stress is reduces with the as the BCI content is void contaminated index is increases, and exponential relationship is developed between peak shear strength and the void contaminated index. Coming to the results of particle breakage of conventional ballast in RCB, from figure A, it is seen that in case of rubber coated ballast sample is very negligible particle breakage as compared to conventional ballast. In second figure, we have seen that as the void contaminated index is increases, the breakage is also reduces due to lubricant, due to cushioning effect provided by the clay fines which is present in the between the ballast particles. Coming to the conclusion, the first conclusion is from the mechanical test. It is from the mechanical test, the crushing, impact and weathering resistance are 75%, 66, 96 and 75% higher than conventional ballast in case of rubber coated ballast. The second conclusion from the direct shear is we have geogrid reinforced RCB 50% is the shear strength is higher or equal to the unreinforced conventional ballast, and the shear strength is reduces as the VCI content increases. In case of rubber coated ballast, we have seen very less particle breakage as compared to conventional ballast. And finally, we have concluded that geogrid reinforced RCB 50% was performed considerably better than other samples. These are the few references, and thank you for paying attention.
Thank you, Makib. Anyone have questions? No? No questions? Okay, I'll put one. Well, I know that you guys are really into trains. I didn't know that I was coming to a train session. But I just remember trains when I was a kid, I was playing with them, and today I'm riding them, right? So my question is, there is a demand for these kind of technologies to improve comfort because, you know, as a user, usually I use it much when I travel. Like in Japan, trains are fantastic. I don't know if they use this technology or not, but they are this demand for these comfort technologies.
Sorry, repeat.
I said, well, I want to understand the purpose of your research. Where is the demand for these kind of technologies addressing comfort in the stabilization of the, I don't know the technical names, but the rocks, the bed rocks that fulfill the tracks. Are you not following?
I didn't understand.
No, I will try to understand if there is a demand for this kind of technologies and where is it?
Demands.
Yeah, demand.
Yeah, the main demands is if we increasing the speed of the train, the particle breakage is increases. If ballast get fracture or break, we have frequent replacement will require. If we coated the rubber coated ballast sample, the particle from the results we have seen that the particle breakage is very negligible. The replacement of ballast is the time is increases. If generally in India every 10 years we have screening screen the ballast, it will very high cost. If we use the rubber coated ballast, it is approximately 4 to 5 times the serviceability will increase. That will very helpful. And further research is on going. Thank you, sir. Yeah.
You know that rubber is a polymeric material.
Yeah.
It undergo degradation reactions with temperature, with chemical environment, and also with the pressure. So have you taken any, this consideration you have taken while doing this study?
Sorry, sir, I didn't.
You must take care of this thing also,
yes,
because this is a material which is already degraded.
Yeah.
So it will be further degrading in the environment where the your blasters they are used.
They will contaminate.
Not only contaminate, they will degrade. Material will degrade. So whatever property you are getting right now, that property will not remain same. It will keep on changing with time. So that must be kept in mind.
Okay, I will check in cyclic test.
You do that, but
Okay.
I am saying that you take care of that also when you're doing your study.
Okay,
Thank you.
Thank you.
Okay, thank you. Okay, let's proceed.
Okay, so I'd like to invite our sixth speaker for this afternoon, Madhavi, who will present us a paper titled Use of Natural Core Fibers for Improving Liquefaction Sustainability.
Good afternoon, everyone. I am Professor Madhavi Lata from Indian Institute of Science. This is located in the southern part of India, 115 years old institute. You are seeing the main building picture of our institute in this slide. So my presentation is on a very simple topic. In the given 10 minutes, I will try to convince you about a sustainable method of mitigating liquefaction. So to be very brief on the physics of soil liquefaction mainly happens in saturated cohesionless soils under undrained conditions. And as per the literature and the studies, this is the most damaging hazard associated with earthquakes, even compared to the ground vibrations and building collapse. So what triggers liquefaction is mainly because during cyclic loading conditions or sustained monotonic loading conditions, cohesionless soils under saturated condition will be subjected to grain separation, and there will be a tremendous increase in the pore water pressure, leading to the flow under constant shear stress. So looking at this physics, we can actually devise methods to stop this liquefaction in soils. And I have given you in this slide what are the mitigative measures which are commonly used for stopping liquefaction. Grain separation, I can go to my next slide. These are the conventional methods of liquefaction mitigation. You can use compaction. You can densify the soils, because the main reason why soils liquefy is under loose conditions, when they are subjected to undrained loading, there is a positive pore water pressure which is developing in the soils. And if you densify the soils, the pore water pressure which develops in the soils becomes negative pore water pressure, and hence you will never have a zero effective stress happening in the soils. So densification is one of the conventional methods. And then you also have drains. These are meant for quick dissipation of pore water pressure which develops in the soil, so that you will never reach the zero effective stress condition. The other method is cement, use of cement, because I said liquefaction happens in cohesionless soils. So if you try to induce cohesion through cementitious materials, then you can stop liquefaction. Another new method which has come into picture recently is biocementation. Use bacteria for creating this precipitation of calcite, which creates artificial cohesion in the soils. But the long-term application and maintenance issues of this method is still under research. So another method is use of reinforcement, because liquefaction is a phenomena in which soil loses the shear strength completely. So if by means of reinforcement, if you induce a confinement in the soils, then it will be able to hold the soil together, so it stops liquefaction. So these are the different methods. The problem with all these methods I have told you so far is they are energy intensive, they use cement and polymers, so these are not sustainable. So what is the best suitable or one of the natural methods to stop liquefaction? So we started this research on coir. Coir is abundantly available in India. The global coir fiber production, if you see, 80% of it is produced in India. It comes from the coconut plant. From the husk of coconut, we prepare these coir, and it is being extensively used for reinforcement applications. But in this study, we try to understand the potential of coir in liquefaction mitigation in a sustainable way. This is a very welcoming kind of a trend, because the coir can replace polymers, and this is a plant-based material, and it produces zero waste. So how does coir relate to sustainability concept? Very simple. There is zero waste. You don't have any waste. And then it also reduces the use of cement polymers. So that way we are reducing the carbon footprint. And then it is a very innovative and sustainable method. And you can simplify the construction process. So in that sense, we have a lot of sustainability inbuilt in this coir-based inclusions in the soil to mitigate liquefaction. Now coming to our study, we tried to do cyclic simple shear tests. Compared to many liquefaction studies which we conduct in lab, cyclic simple shear tests are way ahead, because they can clearly represent the rotation of principal stresses, which doesn't happen in other tests like cyclic triaxial test. So when we do this cyclic simple shear tests on sands which are actually reinforced with coir fibers and create cyclic loading conditions, then what happens? We try to see like whether the coir has any effect on the liquefaction response of these sands. So we used natural river sand of Kaveri Basin, which is a river flowing in the southern part of India. And these particles in this sand are highly liquefiable because they have rounded shape. Rounded particles are easy to liquefy because they roll on each other and they get separated very quickly. And then I have given you in this slide the properties of the sand we have used. We have actually chosen the sand which is very easy to liquefy in real field. And then the coir fiber is collected from a local vendor, from the coconut husk. Directly we have purchased and we have characterized these materials. Now we have carried out tests with inclusion of coir fibers, without coir fibers, and 0.25% by weight of the total weight of the sample, and 0.5% and 0.75% of the fiber we have included. We have mixed this coir with the sand and conducted cyclic simple shear tests. And if we see this plot where I have plotted the liquefaction resistance curves, clearly when you increase the coir content in the soil, you have better mitigation of liquefaction. I will try to explain it through the physics which I have started this presentation with. The first point is pore pressure generation, which leads to zero effective stress. When you do not have any coir in the soil specimen liquefied within 9 cycles of loading. Whereas if you put 0.25% of fiber, which is very, very small amount, you can actually increase the liquefaction resistance. The soil doesn't liquefy up to 26 cycles. And by using 0.75% of the coir, you can actually make the soil resistant to liquefaction up to 65 cycles. Very clearly visible through this pore pressure ratio response. Here the pore pressure ratio is the ratio of the excess water pressure to the effective vertical stress. When it becomes 1, then the soil is liquefied, theoretically. Now coming to the shear strain accumulation, in geotechnical engineering, we see that when you have double amplitude axial strain of 7.5, then your soil is liquefied. So if you understand the shear strain accumulation in specimens with and without coir fiber, we see that a lot of improvement in the delay of liquefaction when you mix coir fibers in the soil. And then the next, another physical aspect is stress path. The stress path is like when the soil goes through non-liquefiable state to liquefiable state, that is critical state, it moves along the stress path where it reaches the critical stress path very quickly when you don't have coir, and when you have coir, then the traversing of the soil particle from no critical state to critical state is highly delayed. And then stiffness degradation is another aspect. Whenever you apply cyclic load, the modulus of the soil degrades quickly. 50% degradation of the stiffness is usually considered as dangerous for liquefaction. And we see that with the increase of coir fiber content, we can actually reduce the degradation index by a lot, as you see from this plot. Another very interesting plot is the hysteretic response. The hysteretic stress strain loops widen very quickly in case of unreinforced sand, and these get delayed in case of reinforced sand. So this undoubtedly proves that coir has very great significant effect on the liquefaction response of the sand. Also the energy what we have calculated, you need lot of energy to liquefy the soil in case of coir reinforcement. Now we've also applied this to large scale modeling, shaking table model tests, where we have used coir fibers and subjected the soil to liquefaction, and you see that unreinforced sand bed liquefies within 4-5 cycles, whereas coir fiber reinforced sand has sustained large number of cycles before liquefaction. So this is the pore pressure response. I'm not going into the details. This is my final slide. The governing mechanism for this kind of behavior is when you put these coir fibers, they do 4 things. Number 1, they put extra confinement. Because of that, you have no liquefaction. Number 2, they also intervene with the particle separation, and they don't allow particles to separate easily. Number 3, they also create interlocking effects. Because of that, the soil particles are intact. Number 4, they also reduce the interstitial pressures, thereby allowing the effective stress always to be positive. And the main, before you ask this question, I am telling myself the question you pose is, what is about the biodegradability of these coir fibers? We are working on that. We are collaborating with chemistry department to make these fibers non-biodegradable. Thank you so much.
One question. Okay, good.
Professor Madhavi, thank you very much for the great presentation. I have this question. Have you done any research on the field application of these fibers? How would we apply these in the field for liquefaction?
Not yet, to be honest. We have started with element tests, applied it to large scale testing in shaking table. The next phase would be to apply in the field. We have to gain confidence before, because I said biodegradability is a question. So we have to make non-biodegradable coirs to make it, to apply it in the field.
Okay, thank you.
Okay, let's proceed. Thank you again. And so we're now calling Sajai Jit, if I say it correctly. I doubt it. With the big title, Sustainable Enhancements of Flexible Pavements Integrate Copper Slag and Fly Ash with Hydraulic Binders. So you have the stage. Start.
Good evening to all. So myself, Dr. Satyajit Patel, Associate Professor at NIT Surat in India. That sustainable enhancement of flexible pavement integrating copper slag fly ash with hydraulic binder like lime and GGBS. Where the industrial waste to be used for the road pavement constructions. So nowadays a very vast road network is being constructed throughout the world. In India, around 35,000 kilometers of roads in next 5 years is being planned, and per kilometer length of road we need about 15,000 ton of natural aggregates. So due to rapid development in the field of transportation, especially in highway sector, the scarcity of suitable graded conventional construction material, that is stone aggregate, there is a scarcity. Due to industrialization, huge quantity of waste material like the metallic slag, non-metallic slag, fly ash and GGBS, one of the byproduct from the steel plant, is being generated. So due to utilization, bulk utilization of this waste in pavement will solve two problems: preserve valuable land from huge dump of waste. On the simultaneously, it will protect the fast depleting natural resources of stone aggregates. The benefit of cemented base or cemented subbase material in the road pavement. In our case, we have stabilized the copper slag to make a cemented base and cemented subbase. So when we use the cemented base subbase layer, the first benefit is the load, the wheel stress or load from the wheel is distributed on a larger area in case of stabilized base. So reducing the stress concentration on the base subbase layer, so improving its life of the pavement. The second one, reduce the moisture susceptibility due to moisture increase. The effect on the stabilized material, it becomes almost impervious material when stabilized base is there. So it will be less, the damage will be less in case of stabilized base due to moisture. Then third one, that rotting will be more in case of unstabilized base or unbound granular material. In case of stabilized base, the rotting will be very low, and also the rotting will occur only at the top in case of stabilized base. So these are the three benefits for using cemented base or subbase layer. Necessity of the present study: the industrial use of industrial waste is lacking on Indian roads because of lack of data about field performance of pavement with these materials. No codes or Indian Road Congress or standards are available to give the detailed design guideline for use of this industrial waste in road pavements, which makes the research gap. So industrial waste, copper slag, GGBS, stabilized with fly ash and hydraulic binder like lime can replace the conventional pavement material without compromising strength and durability. So in this we have mixed the copper slag with different percentage of fly ash, lime and GGBS, and for all the mixes we have done the laboratory test, modified Proctor test, then unconfined compressive strength test has been carried out for 7 day and 20 days curing period. From that, the optimum mixes has been developed, and for the optimum mixes, the wetting drying cycles has been carried out to check its long-term performance. Then the field performance of these mixes has also been carried out. The road sections has been constructed with these mixes, and it has tested at the field. The laboratory investigations, the fly ash material is well known to all of us. So in this case, we have used the class F type fly ash, that is low calcium fly ash, the copper slag obtained from the copper unit in India. So India is the 5th largest producer of refined copper in the world, and its capacity stood at around 1 million tons per year. The physical properties, fly ash and copper slag. The copper slag has particle size 100% passing through 4.75 mm, and it falls in the range of 75 micron to 4.75 mm only. So it is uniformly, that is having more uniform particles, falls in the range of, that is poorly graded sand. The fly ash, low plastic silt. The copper slag has specific gravity very high, 3.24. So the compaction characteristics: with increase in fly ash content, obviously the density will decrease. So due to lightweight of fly ash, and the moisture content also increases with increase in fly ash content. Due to the very fineness, the fineness of fly ash particle increases. The usage test, as per the ASTM code guideline and IS code guideline, the specimen size for UCS test was 50 mm diameter and 100 mm height, and cured for 0, 7, 14 and 28 days. The strength test results for different fly ash content 10, 20, 30, 40, and the lime was taken as 1% and 2% lime content. The GGBS was varied from 3, 6, 9, 12% GGBS, and this result is for 7-day curing period. Similarly, 28 days curing period has also been carried out. And as per the codal requirement for use of any cemented base or subbase material in road pavement, the minimum UCS required for base layer is 5 to 7.5 MPa. For subbase layer, it is 1.5 to 3 MPa. So based on the target strength, we have derived the optimum mixes. So these four are the optimum mixes has been selected. That is 56% copper slag, 40% fly ash, 1% lime, 3% GGBS. The 7-day strength is 3.57 MPa, 28-day strength is 7.19 MPa. So the first and third material can be taken as cemented base layer. The second material has been taken as cemented sub-base layer. The fourth material has been taken as a replacement of DLC layer in concrete pavement. So after selecting the optimum mixes, the durability test has been carried out as per the ASTM code, the wetting drying cycles of up to 12 wetting drying cycles. The weight loss has been calculated. The loss in dry weight of the optimum mixes recommended for sub-base layer is in the range of 3 to 4% only. The loss in dry weight of the mix recommended for base layer is 2.6%, and the mix recommended for DLC layer is in the range of 2.24%, which is well within the permissible limit of 20 and 30% weight loss. These are the few photographs of the construction of test sections at the site. It is a part of state highway in Gujarat in India. The various slags are dumped at the wet mix plant. The steel slag, copper slag, fly ash, GBFS, all these things. The mixing of the material with lime and GGBS. It is mixed with manually with a pokeline, then transported to the roadside and compacted as usual. The finishing layer, bituminous layer, binder and wearing course. So the after a test is section is constructed, the field test has been carried out using a falling weight deflectometer purchased from Diana Test. So falling weight deflectometer is the modern technology to evaluate the road performance. So the working principle, the load is applied through the hydraulic oil pressures, and with the help of geophones we measure the deflections, and from that we will get the back calculated modulus of each layer of the road pavement. Similarly, the roughness index can also be determined using a bump integrator, roughness index of the road surface. Then the overloaded truck has also been passed for 30,000 standard axle loads to check the performance of this material under overloading. So these are the field test data. So the copper slag, the mixes has been compared with the control sections. The last two columns is the control section. If you see, the peak deflection is more in case of control sections from the field test. So deflection is more, so modulus will be high. So for the stabilized base and stabilized sub-base layer, the modulus is in the range of 700 to 900 MPa. Whereas in case of control section, the modulus is in the range of 150 to 200 MPa. So this is the roughness index. The same thing in case of control section, the roughness index obtained is quite high. It crossed the limit of 2000 mm per kilometer. But in case of stabilized base sub-base, it is quite below the permissible limit. The result is shows up to the 2 years after constructions. The conclusions, that is all the usage test results and durability test results indicate that the optimum mixes can be successfully replace the conventional stone aggregates without compromising the strength and long-term performance. Thank you.
Thank you for presentation. Anyone have questions? Come on, you are engineers. No questions? It's okay, I have one. For me, I kind of used to see these kind of solutions with the fly ash, but copper slag is the first time with copper slag also. And I wonder, is that too expensive to use in these kind of applications compared to the today's solutions, although they come with a cost for environment?
Yeah, we have done the cost analysis also. So the cost is about 40% of the natural aggregate. The cost reduction is about 40%.
A savings. So that's good. Thank you.
Yeah.
Okay, so I would like to invite the next speaker, which is Marta Kiraga, who who will deliver presentation on tailwater reinforcement length influence on the local scour depth?
Yes, thank you. So, my name is Marta Kiraga and I am assistant professor here in the university. And my speech will be about tailwater reinforcement length influence on the local scour depth. So it's connected with hydraulic structures. This is what I do. And this presentation is like a glimpse of our modeling research, physical modeling in the laboratory. So couple of words about introduction. So I will tell some words about what these hydraulic structures are. So let's start with weirs that are major hydrotechnical structures that are erected across the riverbed to raise the water surface to the necessary height. So we are creating two stands. The upper stand, where we have the water level increased, meanwhile lower stand where the erosion takes place. So this presentation shows initial results of various tailwater reinforcement lengths, influence of the local scour maximum depth and its length. So, downstream of the structure, we have increased erosion processes during the increment of velocity, as well as turbulent character of the flow. So, we provide the test in the laboratory. And we were observed how the length of reinforcement downstream will have impact on the length and the depth on, of the local scour. Yeah, and the following research hypothesis well established. By modifying the design of the bottom stand, the dimensions of the local scour can be reduced, so we have some impact on the local scour dimensions. So hydraulic model tests were carried out on a physical weir that was installed in our laboratory flume. The weir was inspired by existing hydrotechnical structure that is located in Poland on the Radomka River. So our model was designed at a scale, geometric scale 1 to 30, and the model was engineered considered the following dimensions. So we have 3 spans, each is 60 centimeters. Between them we have 2 pillars, each has 4 centimeters, and we have 2 side abutments. So as you can see in the picture, we have 3 slabs, 3 variants of downstream development. Variant number 1 consisted of the slab covered with the riprap, so the material, stone material, and the length of this slab was 60 centimeters. The next variant was the same, but just the length was 1 meter, and the variant number 3 is 1 meter and 20 centimeters. So we used the overflow with practical shapes. We were carried out our experiment in a steady flow rate. The fruit number that was measured upstream was less than 1. And we conducted our research in clear water conditions, so there was no load, no sediment load approaching from the upper stand. To build up our model, we used some acrylic glass, also a sand, paint, some varnish, some glue, as well as various foams to build up the model. So the body of the structure was assembled from pre-cut pieces of acrylic glass. Then we glue it at the joints. So we also used some pipes to create the shape of the pillars, and all the empty spaces was filled up with a foam. Oh, sorry. So, results. In this figure, we can see the maximal scour depth. and as well scour length. So these green lines are devoted for scour depth. Meanwhile, these gray one are for scour length. So as we can see, the performed analysis allowed to the sandy bed formation description and to depict this evolution of local scour in particular tests, time steps. What is more, data analysis allows to determine the maximum scour depth and as well the extent of local erosion and determine the progression in these subsequent time steps. So we observed that in variant number 1, so this shortest slab covered with stone, we could observe constant increment as well as in the case of the maximum local scour depth as well as the length of the scour. Meanwhile, in the case of variant number 2 and 3, they were just stabilized. So here in the picture we can see an evolution in time of our of the scour. Sorry, there is one extra feature, as I can see here as well. Maybe I will try to remove it. Oh. Okay. I don't know how to get rid of them. However, sorry. It's not working. Okay. Okay. So again, we saw the view, like the plan view, and now we have some graphics, some 3D depictions of the phenomenon that we were considered in the laboratory. So let's go to the conclusion. Despite the fact that the tests performed are of pilot exploratory nature, it as well can be concluded that increasing the length of reinforcement in this downstream stent has no longer a pronounced effect of reducing the depth and length of the local scour. After a period of 8 hours, because this was the time of providing our research, it was found that the rate of increase the depth decreases first, and then the scour length stabilizes. So the first is the depth and then the length of the scour. As well, it should be noted that the model tests, including pilots in hydraulics, are carried out to ensure that new solutions or changes to existing models, and they are effective, reliable, and in line with user expectation, and they are very important even at this project stage. So thank you for your attention.
Thank you, Marta. We have time for one question.
Yeah.
First of all, thank you, Dr. Marta. It's for really nice presentation you have carried out. Very detailed experiments on scour depth. So I don't have any question. I just have one curious suggestions, like if we are having the length of those piers, if we have suppose some energy dissipators,
yes,
during the discharge of the water after that section, so then we can further reduce the turbulence, and that may further help you to reduce the length of the wall, because obviously we want to reduce the turbulence as much as possible so that we can reduce the length and we can reduce the cost of the structure also. So, and the same time, if you will use some, if you have the wall and if you will use the some holes in these particular walls, so that the air trap that generally happen due to the passing of the water, that can also further reduce. So that two things may help you to reduce the turbulence. And that may, I think, it might actually just some of the field work I have seen, so that may help for you. Okay.
Yeah, I think we will discuss it as well during the dinner.
Sure,
I think so. And we should think about, like joining the points of view, because as I know, you are also hydraulic in your work.
Yeah.
So yeah, I think it's a good idea and, good point of view from you. Okay.
Thank you.
Okay, thank you. So, our next presenter will be my student, my fellow student, was not my anymore, but was Maurits. I think I said it correctly. Exactly. Well, I hope. And and the topic will be circular economy, sustainable engineer, renewable energy, and the existing results of contemporary world. It's all there. Yeah. Oh, it's your topic. Oh, sorry. Oh, you're here. I didn't know. Okay, sorry. Laboratory studies of scoring downstream of the air. I think it's a river.
Weir.
Yeah. Fish? No?
Yeah. Thanks. Good afternoon, everyone. My name is Maurits Najwajko, and I'm a master student at Warsaw University of Life Sciences here. And today I have a pleasure to perform in front of you and tell you something about the researches that I conducted for my master degree, for my master thesis. So the topic of my presentation is laboratory studies of the scoring downstream of the weir. And on the title slide, I also put the 3D visualization of the weir that I have been testing for my engineering degree, and I have a small sentiment for it. So we don't have much time, so we are moving forward. So what is the purpose of the study for my master degree? I'm checking the efficiency of energy dissipation for 5 types of reinforcement in the lower position under the weir. And why energy dissipation is important? It is important because water has a very big power. I put this image here, this photo, especially because when I'm thinking about the power of water, this photo gives me a very good example of it. This photo is taken by me this year. It's a Narew River in the Podlasie district in Poland, and you can see a riverbed here. And I took it from drone. It's a really nice equipment. So to test it, we had to construct a physical model. To design it, we analyzed the 10 real objects, these damming structures on the territory of Poland, and one of them is weir near the village Piaseczno, near Radom city. And we constructed our model from the plexiglass. We glued it, we filled the abutments, the pillars with foam, and then we covered it we insulated it with silicone, and then we covered it with paint, and it looks like that on the right side. And this is our laboratory flume. On the left side, when we finished building our model, as you can see on the right side, it's with closures here. We put it in the flume, we insulated it with silicone, and we were ready for testing it. So, construction of reinforcements. For the realization, the goal of our research, we construct 5 variants of reinforcements, and this is the first one of them. It's just sand, so I don't have any photo of filling the flume with sand. But I thought that taking photos from drone can be a very good example of it. So I really liked the drone view from the photos, so thank you, drone. Oh. Okay, so that's the second and third one variants of reinforcement. You have photos how it looked like. It's a reprop and reprop with gabion structure. And here we have fourth and fifth types of reinforcements. It's baffle blocks on the upper image, and the corrugated concrete slab on the bottom. So how did we do measurements during our research? So if it goes about the measurements of velocity, we use the PEMS probe on the left side. And if it goes about the ordinations of the water table or the bottom of coordinates of the bottom, we use the disk probe. And the results, all the data from our measurements we take into the Excel spreadsheet, and then we make special tables for taking it into Surfer. It's a very nice software, and you can see visualizations for the variant 1 was no reinforcements on this end, and the variant 3, which was reprop with Gaussian structure, the best variant in our results. And you can see the difference in the scoring of the bottom, looking just for the ordinates, because in the variant 1 case, we are close to 26 centimeters from the reference point, and in the variant 3, we are on the 45 centimeters from the reference point. So the difference is very big. Then we also created the yellow lines of bed relief in time for also variant 1 and variant 3. And as you can see, the difference is very big. So then we created the stream velocity distribution in sections A, B, C, and D for subsequent time steps. This is only one example of it for the variant 1, series 1. For each variant we did 11 series of research. And then we created some tables, and using a pivot in Excel, it's a plug. We created some diagrams like this on the point A and point B. It's a measurement 1 and 3. We did 3 times measurement for each series. Once was after half an hour, then second one was after 2 hours, and third one was after 4 hours. So thank you for your attention. And only a small conclusion. After looking at this comparison of the variants, we can say, only simple because we don't have much time, I can see, that we have to use reinforcements because the effect of the bottom scoring, in case we don't use them, is very big, and it's a really big hazard for us. Thanks.
Thank you. Okay, thank you so much, Moritz. Anyone have questions on this? Okay, you go. Maybe the microphone over there.
Once again, thank you so much for your presentation.
You're welcome.
It's really nice. I can see as a hydraulic engineer that it's love to see that the kind of experiments that you people do. And this only one thing I would like to add, like if we create the bucket at the downstream, so would it affect the scoring?
It affected, yeah.
So I think so our purpose is to like reduce the reduction, or you can say score depth, because that only will help us to protect the structure, otherwise it may have failure. So this is the only thing I would like to say. Like if we will create the bucket, so you can add in some other experiments to create the bucket and see that how it is behaving.
Okay, thank you and appreciate a lot.
Okay, thank you.
Thank you.
Thank you. And I would like to invite our last speaker for this evening, afternoon, Teresa Bielańska, who will present a paper titled Circular Economy, Sustainable Engineering, Renewable Energy, the Existing Results in the Contemporary World.
only, very short. My quick. Okay, I don't know how to move it. Sorry, it's not my laptop. How to change? No, it's not moving. What about the mouse? Maybe I can use mouse. But it's maybe not visible so much.
And then you can do like this.
Okay, okay. I don't know if this is visible. Okay. So it's a few words about me, but it's not maybe so interesting. I am the international consultant for the last maybe 15 years on the international market. And what is the most important for me, how to use amazing technology and to fit this to the real life. And just now my topic is the circular economy, sustainability, and the reuse of the energy in the contemporary market. And I think that the best example is Dubai, because I am addicted on Dubai. But why it happened? Because if you imagine that the people were sitting in the middle of the desert 50 years ago and was thinking about amazing contemporary city in the middle of the desert for 4 million people not having even enough water. So this was a great step on the contemporary engineering to this. And what is the most important? To reuse the energy, of course, and to reuse the water. There are the most important three things in engineering, in my opinion, too. One of them is motivation. So they were sitting in the middle of the desert thinking about the first motivation. The second point is awareness, why we are doing something. But the next point, many times people using money. But for me, the money, in my opinion, money is not so important. And the ideas and the dreams are maybe more important if we want to see how amazing is Dubai now. So you see many palms in the recirculation of water systems and millions of flowers in the middle of the desert. So this is amazing situation, seeing this, being in Dubai. You see, especially in spring or in autumn, you have a lot of this kind of the elements. And what is the most important, if you see this on the Al Qudra lakes, there is the complex of the artificial lakes in the middle of the desert with animals, with fishes, birds, and amazing place even for barbecue, what is very popular in Arabic countries. And the next point, what is very important, where the nature can't do something, engineering can. This is the most important. We have to use the most comprehensive technologies in this kind of the elements. And I was very surprised of Dubai, especially that my profession is, I am mechanical engineer and plumbing in English market. So it's Inżynieria Sanitaria and Sarna in Poland. So I did a lot of ventilation, air conditioning, drainage, sewage systems. So it means it's very important for me because in Dubai we don't have, as you maybe imagine, we don't have drainage for the rainwater. Because in general there is no rainwater. This year was a little bit different, but was a different story with some experience on the weather in Dubai. When rainfall happened, in 2 days there is no water because was evaporation in the city, and it was the reason there is useless to use money for the using the very expensive system. But the similar story is it is a wastewater treatment, is a wastewater system, because they use a tracker for everyday collection of the soil from the development, for example, and 80% of the water is reused locally for recirculation, for flowers, for grasses, palms. It means the most important is very short circle to reuse water, energy, cooling, a lot of these things. And also I know that probably you feel that we have a lot of water from the cooling system. If there is something as a hot country, 48 degrees for the calculation, it means there is a lot of condensate. And if there is a lot of condensate, you have a lot of water to be clean water to be reused, especially for this purpose, as I am showing here. And I would like to show you all coral lakes, as you see, for barbecue, very popular. And can you imagine the water around with so many birds? There is an artificial lake for the waste from the wastewater treatment plant. And when we don't have so big system of the wastewater and the network of this, can you imagine 100 kilometers of the system with the pipework, with big pipeworks? For example, 1 meter pipework size is very normal. Instead of doing this, we can do the very short circle with the reuse of water. As I said, 80% of the reuse water. So it means that everyday tracker brings this waste, the soil, to the wastewater treatment, and only 15% is treated in this point. So it's much cheaper. And what is nightmare for the mayor of the city, if there is a network maintenance, millions pounds, dollars, it costs every year, to keep the system. But they were thinking about this 50 years ago, how to create the system and how to play with this for the future. On the left hand, maybe I will develop this a little bit more. And this is amazing, because when they started in Emirates thinking about the new technologies, they didn't have any technical universities, the technical base doing this. So they use American people, British people, using their standard to create something what was going rather on the base of their dreams. Because they build the city, it's one city in the world, this kind of the new technologies use a lot of this amazing situation, what is very top engineering. So you are sitting in the middle of the desert thinking about something what will happen in 50 years. So it is amazing. So seeing this, for me, Dubai is the city full of engineering, and this is the top engineering use. And you see on the left-hand side is the Museum of the Future. Is a columnless structure, so there is no column inside, and there is on the elevation you see some Arabic letters and some symbols of Arabic word. The same story is inside as an inside elevation. And because somebody did ventilation and air conditioning for this, I know how it was difficult to locate the grills, diffusers, a lot of these things. On the right-hand side is amazing waterfall, of course artificial waterfall, is of course with the lighting. And if the sensor is showing that the ship or anything was trying to pass the bridge, the water stopped. So a lot of the things are very important. And so, as I said, the most important is a short circle of this of all services. And the next point is, because I am the vice chair of the Polish engineers in Great Britain, Association of Polish Engineers in Great Britain, Twice a year we are doing workshop in Dubai, spending 3 or 4 days in the bus from early morning to very late evening, trying to see these amazing things in Dubai, in Abu Dhabi too. And this year we will go on 16 to 24 of November to show Polish engineers how is the real amazing contemporary engineering in Dubai and Abu Dhabi, to give them the motivation, because this is the most important, to have the motivation for engineering, for any our activities. Thank you very much.
Thank you. Do we have any questions? So just one very quick from me. So what is one, maybe the technological solution that you would like to see being exported from Dubai to the Western world? If you could.
It's maybe not ventilation or air conditioning, because there is no hot weather in Europe, but I think that the wastewater treatment, to eliminate the very long sewage systems in the cities, because I know how it is. It's a nightmare for London, for example, if you have very, very long distances of this pipework.
Thank you. So this is bringing us to the close of the afternoon session. Thank you all the speakers. A round of applause for the speakers, please.
Group photo? Okay, so I'll call all the speakers to the stage to do a final group photo. And after, I think we'll have, I don't know, if, well, you have to look out the agenda. I don't know if as another session. I think so. No dinner? I think it's dinner. Okay.
Yeah.